Are we? Okay, everybody. Hello. You look really good today. I'm really happy to see all of you here. My name is Alan Ising. I'm standing here pretending to be Lasse Jarlskov, who couldn't be here until in a couple of hours. And it's my immense joy to welcome you to DKNOG12. It is technically our 11th conference, but on the 12th year since we began. Before we go into some practical details, let's just spend a moment commemorating DKNOG10, the conference that was. DKNOG10 was supposed to be our big celebration, our 10-year anniversary. We were really, really happy to welcome you there. But as you may remember, the day before, some stuff happened internationally. I myself was sitting out with the speakers and sponsors who had arrived a little bit early. We were sitting out and having a good meal before the conference. And then suddenly my phone went crazy with lots of text messages asking me if I've seen the news and what our response was going to be. Obviously, I hadn't seen the news and I did not know what our response was going to be. But somehow we wanted to have something, and the day after not sleeping at all, I stood here in a very empty room, standing in front of a camera, trying to run the very first lockdown online conference. And I think we managed to get a program running, and I want to really thank everybody who was involved in that, either providing remote talks sort of ad hoc, phoning in on whatever software was available at that time, or people who were just there giving me the much-needed emotional support. And I also really want to thank our sponsors back then who really helped us out getting through that part. Especially I want to highlight two sponsors from DKNOG10, NetNod for always being there for us. Really, really thank you for that. And I want to thank SEC Datacom that helped us distribute all those nice hoodies to all of you people, so you got that stuff as well. So, let's see, there. So that brings us to today. Look at us now. We are 224 registered participants. I'm not sure there's 224 in this room at this moment, but I'm sure we'll all be here at some point during the conference. And that is a record number. It's not 100% over, but it's more registered people than we've ever had, and there's a lot to be proud of in there. We are outgrowing these rooms, and that is fantastic and a little bit scary. But again, it is tough to run a conference for 224 people, so I want to highlight again, first of all, our platinum sponsor, NetNod, again, sticking with us since day one. Thank you, NetNod. Then we have our gold sponsors. I'm always happy to see both new and old familiar names here. We have Kentic as a new gold sponsor this year. They're joining our little family of well-known good friends of DKNOG. Juniper and NetNordic have also been with us from the beginning. We have our silver sponsors with also very many good familiar names and new names as well. We really want to thank both our gold and silver sponsors heartily for standing with us here. And then we also have finally our associate sponsors, again really well-known names here, and the associates tier is really where I give a lot of love to these people, because some of these are smaller players among us. Like we have the Danish Internet Exchange has supported us many times. We have Arista, we have Drive NCC, and we have Norlys as a new sponsor this year. So also thank you to them. So DKNOG is technically a regular association. That being said, we have not been very good at being an association. It's not a natural thing for us. We like to do conferences. We don't like to do board meetings and other boring kind of stuff. However, we need to be better at being an association. So we have a general meeting coming up later this May. I'm writing here in the slides that the 16th seems likely. The 16th seems unlikely at this point, so new dates will come. It will be both physical and online, and if many of you join us at the general meeting, maybe we can go out and eat afterwards, or make it a little bit nice and social. Let's see. But I really want to try to convince you people to sign up for the general meeting when it gets announced. Either just helping us run the association or even volunteering for the next year's work. Organizer burnout is a real thing. We don't want to burn out our organizers, so please, we accept all the help we can get, no matter if it's just coming here in the day and just setting up a couple of banners, or whether it's running the program committee or helping in whatever way you find you have the possibility to. We really need your help, and we welcome it with open arms. So keep an eye open for the link. We will post it wherever we can. We have our regular channels, the RSC channel, where many of you already are idling most of the time. We have new modern media such as Discord and Slack, which are mostly idle as well. But we can make it work. If you really want to chat with us on Discord, we'll figure something out with that. If you prefer Slack, we have currently a non-functioning bridge to the IRC, but we'll get that working again, so we can bridge the communities together no matter what platform you have. We also have presence on Twitter, on Facebook, on old school mailing lists, on LinkedIn. Maybe we'll get on the next big thing, whatever that is, Mastodon, I don't know what. But you can find us wherever you try to find people online. Not on Tinder, though. Let's see. A couple of practical details. When the program is done, we'll have buses that will ferry us to the social venue, which is Teaterkilleren. If you want to go yourself, go to our website, go to the social venue page there and find the details such as the address. The program says when it starts, but it's very soon after the last program point, so don't think you can take a nap or a shower after that. Go to the social. It's going to be an awesome social. We will try to send out evaluation forms sort of running through the program. We'll see, maybe they'll be there at the end of the program. Many of you will be interested in sitting and doing work instead of following the conference point. You might need power to your laptop. It's a little bit self-serve this year. There are boxes with extension things around the room, so please help yourself there, but don't make death traps that people will fall over. Other than that, I think that was all the practical details I could come up with, and all the slides I could come up with as well. So once again, really a huge welcome to all of you. Thank you for coming to the DKNOG, and we'll talk later.
Hello. So, welcome to the first program point. We are just going to leave Alan standing up here because he's the first guy on deck. And Alan will talk about some automation stuff. So let's see how that goes. It's all yours, Alan.
Thanks. I'm just waiting for some new slides. All right, let's see if this works. It does. Good. So, hello again. I've taken a hat off and I've taken another hat on. You get to see me again. I'm now wearing my work hat, my actual work hat, instead of my volunteer hat. The talk I'm going to give you today is called Automation for Brownfield Networks, Designs and Experiences. And this is a talk that could have been hours long. Fortunately for you, I only have half an hour, so I will touch upon some things and some experiences and design, things like that. But I won't be going as deep as this talk could go. But hopefully I can come back another time and continue where we left off. Which way do I point this? There. Yeah, good. So, I'm Alan Ising. I've said that a couple of times now. I work as a network automation architect at Telia Company. I'm based in Oslo these days. I have been for the last almost 5 years. I've worked in various business-to-business kind of service provider companies for the last 15 or so years. And I've spent about the same amount of years wishing we had better provisioning. When I started in this industry, when I had my very first job while I was still studying, I worked at a small residential ISP. Well, it wasn't that small. It was a residential ISP that had a great piece of software with a big button that said provision. And once you clicked that button, things magically worked. Then I got my first real job at a sort of business-to-business kind of service provider. Not a provider that exists anymore. But there, when we provisioned the customer, we opened an SSH connection to a switch, then we typed some commands in, then we opened another SSH connection to another switch, and so on and so forth. And I just wished that that provision button was there. It's not working very well, this. Where do I need? There we go. I'm going to use the terms greenfield and brownfield in this presentation. If you haven't heard of those terms, it's greenfield deployment is basically when you deploy to as a completely new network, completely new automation. There's nothing in there before. You're not bound by any legacy or anything like that. But brownfield is when you try to integrate with something that's been running for a long time. In this case, we had an active network that's been running for a long time. We also had an active provisioning and automation platform that we had to replace. It's not working very well, this. It's going to be a long talk if I have to wave like this. So the network automation I'm going to talk about today is based on a project I've been part of for the last couple of years. 2 to 3 years I've been working with this project. I'm not going to talk about the project itself. It's just the basis of the foundation of my experiences here. But I'm going to focus on some of the architectural choice the approach we had with automation. We based our automation on Cisco NSO. I'm not going to talk specific Cisco NSO solutions today. I'm going to try to keep this very generic. Cisco is not paying me any money to advertise their product, so I'm not going to do that. Good. It's business-to-business services. If you're not familiar with those kind of services, it's layer 3 VPN services, internet transit services, layer 2 solutions, etc. And these are very challenging to automate because they're usually a lot more complex than residential services. This is usually because there's a high degree of bespoke, or what started off as being bespoke, and has become now a myriad of add-on, value-added services, etc. And these are even more complex given that many of these networks are large and old, have various parts of the network with legacy technology that also needs to work with all these various add-on products. So that makes it extremely complicated to properly model these things and automate them. The biggest challenge there is definitely documentation, reconciliation of documentation with reality. So you must import your services into your new automation, and that must not only just be correct documentation, but the output must also match whatever you had in the network there, which might not match completely with your documentation. If this doesn't match, you have to do manual intervention, and that's an expensive process, takes a long time, and you want to avoid that. Let's just quickly walk through the overall architecture that we want to build in order to make a scalable automation framework here. This is sort of an idealized architecture. Less can and will often do. That said, there are some principles here that we want to stick to. On the top of the picture, we have the OSS stack. There's stacks and stacks on top of that, for example, sales and BSS. But in terms of this, this architecture will start at the top with the OSS layer. Here we have two components that are interesting to us. We have the SOM component and the ROM component. This is the Service Order Manager and the Resource Order Manager. Our network automation here, I've called a domain orchestrator. I'm going to use a lot of different names for this stuff. But the domain orchestrator is meant to indicate that you can have multiple automation systems depending on what kind of network you're working with. If you have, for example, I was working with the IP MPLS domain, so that would be one orchestration platform. You could also have another one for SD-WAN, for example. It's up to your service manager to direct the requests to the right domain orchestrator in order to produce the correct kind of services. Then we have various activators which are done for scaling purposes as well. So if you have a very large network, you want to have multiple nodes communicating. Maybe you want to have one for your CPs, and maybe you want to have one for your core backbone network. The resource orchestrator is responsible for handling everything that has to do with resources. So that's usually inventory-related operations, getting IP addresses out of a system, or allocating VLANs, or creating or removing devices from the network. And we want to have this architecture so we can separate concerns between services and resources and achieve what we will call for the intent-based orchestration, which is a bit of a buzzword, I do acknowledge that. But in this case, it means that we want to keep the realization away from the service configuration. It's sort of to say we want to split the what from the how. So let's try to sort of understand what we mean by this by going very much at a simple example here. Let's say we have, well, this is barely visible on screen, but imagine there's some Cisco config up there. So imagine we were going to configure an internet service. We have a simple configuration here, interface gigabit Ethernet 01, IPv6 address, something. Usually when you do this, you want to use a template because that's what every piece of automation software does. It uses some sort of template somewhere in the system, whether it's like Ginger style like I have here, or it's some XML stuff like Cisco NSO does, doesn't matter. You usually want to do that, and you assign variables like interface, IP, and prefix wherever it makes sense in your system. Then you would have some sort of activator or some sort of automation software that has the prime responsibility of assigning values to those variables, and that's fairly simple at this point. But then you can create a public API with that, and suddenly got something that looks like that. So you have a service ID, and you have those parameters that correspond with your template. But the challenge here is that you're now mixing resource and service parameters together. So let's say you store this as your service information, but next week you decide to decommission this router that has this service, and you then have to rewrite the service. Is it the same service if you change these parameters, or do you have to modify it every time? What we can actually say, it's the same service intent. So we usually say that the northbound system, it communicates intent to us, and it pushes the intent to the activator or domain orchestrator or whatever we want to call it. So in this case, then we have instead a state of the configuration that we manage on the southbound side of this. So on the top side of it, we can say our state is I want an internet service with IPv6. We push that into the activator, and the activator interprets this as I need to push an IPv6 address so-and-so on this and this interface. In this very simplistic example we're working with here, we are just actually reduced to just a service type, an address family, and something we call an endpoint here, which is a point of reference to where we want this service to be present. Our activator then interprets this and says, okay, I need an IPv6 address in order to fulfill the service intent. So let me ask my resource manager, my inventory system basically, please give me an IPv6 address, and it will give that back. And now we have everything we need to provision the service. And this is really sort of the core concept we need to take in order to scale this up. We're storing the, let me see. Yeah, we're storing this blob here. This is actually our service configuration. This is a service graph, and this is the only information we need to store in order to produce the service. Then we can move it around and change the definition of this endpoint 100 to something else, and we can produce it somewhere else in the network. It might look different, but it still fulfills the original service intent. So this was our goal, to do this on a large scale for business services. So we scaled that up, this thought up to layer 3 VPNs, internet transit services, business internet, layer 2 VPN point-to-point, etc. And I've sort of included a simplified version of that on the right here. And the challenge here is this works for new services. Of course, we can program our service to do the right thing for new services, but for old services, there might have been made some decisions in the past that doesn't actually match what we would do today. So we had to break the model a little bit, put a lot of hooks into it, so we can say, no, don't use that VLAN, but use a different VLAN, or use a different link net, or take a different route through the network. But the challenge is really here, and it's really dependent on mapping the resources correctly in the network. So let's put the first undeniable truth out for the day. It cannot be understated how impossibly hard it is to perform clean data migration. So just for some context, how many in this room would be able to recreate their network service for service just from the documentation? Rancid doesn't count. No hands? Thought so. But nevertheless, this is what we need to be able to do in order to have the automation at this level. And there's really, really no way around it other than just cleaning up documentation until you're done. And it's going to be super, super meaningless work in many ways. And the worst part of it, it's work that you need experts to do, experts that are usually very busy with things that actually is meaningful. Instead, they have to spend time cleaning up Excel spreadsheets and writing parsers for the network to figure out which router ID you used in the network and things like that. But the thing is, when you start this work, you need to pick an approach. Let's see, I'm ahead of myself here. You need to make a choice, basically. Do you want to automate in the way where you reproduce what's in the network? Or do you go for an approach where you create a new configuration standard, something that's simpler to automate, one common standard to sort of rule them all style? And it might be extremely tempting to go for this functional equivalence road, just saying, it's too inconsistent in our network, we can't automate this, let's just make something new. However, I would actually advise some caution there. Because when you go for the exact output, and we did that, you can measure your success rate. You can start producing your services, and you can figure out how well your automation works. And we did this by loading all our services into a clean environment, then just using the driver functionality in NSO. I know other automation software systems have that functionality as well. You basically just apply your configuration. You get a list of changes that this has caused, and you analyze that. So we basically wrote some software that went through these and categorized them into 3 kinds of categories: in sync, safe changes, and unsafe changes. In sync, of course, means whatever is in the network is exactly like we produced it from automation. That consists of circa 0% of our services. And that's because safe changes are also things like we rewrote the description field slightly, or we just aligned the service to how it was supposed to look. Like there was some configuration statement missing in the network, but our automation pushed it, so now we are doing a change to the service, but it's fine, really. It doesn't change anything, it doesn't break the customer, it doesn't change what we are delivering to the customer. Unsafe changes, on the other hand, is everything we really need to look at. And this could be due to our documentation being wrong, for example. We find a 100 megabit service in the network, but it's only a 10 megabit according to our documentation. Who's right? It's probably the 100 megabit, and we just forgot to update the documentation. Lots of things like incorrect IP addresses and VLAN mismatches indicate more that our documentation is wrong, we are loading the wrong service into the wrong port, things like that. But it also shows what kind of bugs we have in our system. So once we have a high enough percentage of safe changes, we can go live. But once we've gone live, we can start to look at these functional equivalences. We can start looking at what can we change in the way we produce output to make it more automation friendly, to make it more readable or consistent or correct. But once we do this, we cannot do the dry runs anymore. We cannot get the statistics going anymore. We will just get a lot of false negatives, and we can't use it as a KPI. Things that could be automation friendly or human friendly are sort of a little bit fluffy to define, but things like apply groups is a clear example of something that's definitely human friendly, but not automation friendly. That's a number of reasons for that. It could be that it's hard to apply and unapply these apply groups. You don't know what they contain. So there's part of the network configuration that you're pushing out that contains stuff that you don't have control over. It could also be a lot of free text comments. There's usually a lot of that in route maps and things like that. That's not very automation friendly either. Generally, we want to have our service configuration as self-contained as possible. And that's because we don't want to stand in weird ownership situation where multiple services own critical parts of each other's configuration. It's sometimes not avoidable. Things like VRFs is a good example of shared configuration that you need to be really careful about. You need to make sure that you don't accidentally remove the whole VRF definition in your router just because you only know of one service that is using it. Maybe there are more services on the box that was manually provisioned, and then you've created an outage for the customer. So try to make configuration as self-contained as possible. One of the things we spend a frustrating amount of time on is various differences between Cisco platforms. Some of these differences are extremely trivial, but really, really annoying to deal with. It could be, for example, I have an excerpt here of various flow control supports and various Cisco switches. They can be either supported, unsupported, or supported with a default behavior. So if it's unsupported, the command doesn't work, it causes an error, your service provisioning will fail. If it's supported but with a default value, it means that you can push that command, I don't know how many times to the device, it will never show up in the config. And that's also frustrating for automation, especially if you want to see if your service is in sync or not. And then you have like platforms where it's different behavior depending on what speed the interface is on. So this led us to develop an extremely annoying system where we have to flag every non-standard behavior on every interface there is on our switches. There's no way around it, it's just how it is. So once you've reached a good enough quality in your tests before going live, you can actually go live, but you have to be prepared to support your organization a lot. We planned a month of hypercare, as we called it, meaning we had a month dedicated to just having daily bug stand-ups. I sat next to the delivery engineers and I held their hand while they configured services. And it was fine, but we really saw that the need for extra support lasts on for up to half a year. and then it's regular support from there. And the problem with supporting network automation is that a lot of the people who write network automation may not have the biggest service delivery network engineering experience. And there's no burn or anything here. They're excellent programmers, and that's their specialty. But that means that if a user comes up to them and explains what they're trying to do, it might actually be very hard to help them. So you need to have a couple of super users trained from the local organization to just be super users in the system before you can let them loose. And yeah, I could go on forever in this talk here, but most of it will be war stories, and those are best had over a cold beer. So let's take some questions instead, if there are any. Kramsøj først.
Yes.
My name is Henrik Kramselund. I'm from KEA and security. Did you meet up with some configurations that were just too complex, so you went back to the customer and actually reconfigured some stuff? Or
we tried. We have some examples of things that we're still working on this day that hasn't been delivered completely yet, because the complexity is just extremely high. But for various reasons, we haven't simplified it a lot. We have sort of taken a couple of variants where they are functionally the same, but there's some technical reason for choosing the other over the first one. That has to do with, like, okay, maybe it takes a little bit more resources in the router to do it this way. So, and then we've sort of aligned those configurations. We really want to be able to measure still how well we're in sync with what's in the network. So we want to avoid as many of these optimizations as we can still.
Hello, my name is Benjamin, New Day. Alan, what do you do with build to orders and stuff like that? Is that a manual thing, or is that something you build into the automation and then let that build it?
We've been lucky enough to have most of the build to order stuff going on in the CPEs and away from the PE configuration. And the CPEs are a lot more free to have customization there. But we generally try to model our services rather flexible, so you can put in extra net, you can put in an extra routing, and if you need some specific functionality, well, you put it on the CP. No?
My name is Morten. I'm from SmartShare Systems. You mentioned that when you were testing this, you often encountered interfaces with the wrong configuration of bandwidth, for instance. Did you use this as a tool to improve logging and traceability, so you were better able to see why is this interface configured for 10 megabits instead of 100 megabits or something like that?
It's hard to do why in a project of the scale that we had to do it on. So it was more of us being able to say the documentation must be wrong here. Why it is one thing and not the other is too hard to tell, unfortunately.
I'm not asking about correcting the documentation or the configuration. I'm asking about when you use this tool to provision something. Did you add some logging or traceability so you can go back in the logs and say, why is this configured like that?
Yeah, there is definitely auditing functionalities and audit trails in them. I'm not super happy with the functionality we have currently. I want to improve it at some point, but at least for a short time frame, you can go back and see who configured what and type which commands and things like that. So you get some auditing. I'm not super happy where it is right now. I would like to have more visibility of things like that, especially for historic contexts.
Exactly. Thanks.
Hi, my name is Kali from Global Connect. I feel like this presentation spoke to me personally. Did you ever go back and think maybe you should redo some of your documentation? Did you change your documentation to better match how you would like to automate stuff in the future? I feel this is like a bigger problem, especially for my company.
Yeah, I feel you. Documentation is the nightmare of this industry in many ways, and I guess there's really no way around it. You just have to have good systems that do this for you in some ways. I don't think we necessarily improved that much from this project in terms of pure documentation. I'm a little afraid we'll be in the same situation in 5 years, unfortunately.
Hello, Mikkel Troels from Net Nordic. A point about documentation. When you do systems like that, like this, sort of the service documentation is implicitly hidden away in the BSS or OSS system, so you can always trace which parameters got in from which service ordering. So in that sense, you sort of have documentation already in place. As for what is actually configured in the devices, when you do like Alan and pull things out of a resource manager pool or something, you can always see in your resource manager which service request pulled those resources and where they're supposed to be applied. So it actually do solve some documentation issues, I would think, going forward. But of course, not in an annoying brownfield situation, it won't.
No, I don't want to say too much about this because it's kind of complicated, but you need to make sure that you're tracking the right things in your BSS and OSS layer in order to get the documentation level you want. And that has to do with how you model your services in the OSS layer, whether you're actually capturing the right fields or you're just pushing technical attributes back to the user and letting them fill out stuff, and then it's just gone again. You need to be really careful how you design your OSS systems. I'm not an expert on OSS systems, but we spend a lot of project time trying to model products in the OSS layer, and it's complicated. Yeah.
Tom from Cloudflare. Did you, at any given point, considered synchronizing upwards from what you have as configuration and then installing that in whatever other sources of truth that you're using? And if you did consider it, did you go with it or not? Or?
In the end, it was a combination of everything. We did read a lot from the network just to, I mean, we started in both ends and saw what was in the middle when we were done with it. All right.
Hello? Yeah. Well, I forgot to introduce me last time. I'm your chair for this morning. I'm Mikkel, in the DK program committee. So if you want to bitch about the program, that's me, that's Alan, that's Fergus. Please give a big hand to Alan for his presentation.
Thanks, man.
And now you might sense a bit of a theme, because now we have Jan Krillesen from Nordlys also talking about some automation. So please give a big welcome to Jan.
Seats over here, actually, if you want to sit down. So really come join us. Don't be scared to sit at the front. I won't be throwing stuff at you. And thank you very much, Alan, for setting the stage and talking about network automation and introducing terms like greenfield and brownfield deployment scenarios. I think another thing that might help to bridge between my presentation and what Alan did is mentioning the terms day 0, 1, and 2, something we use a lot when we're talking network automation. When we bring on new devices, new routers, new switches, we typically do that in a number of steps. First, they get a very initial configuration. like an IP address, management IP address, a default route, and stuff like that, just enough to be able to bring your device online. That's what we call day 0. Then we have day 1. That's all the router-specific configuration that does not include customers. So that would be the IP address of your route reflector, which interfaces are running LDP, and all stuff like that. So if you have day 0 and day 1, you have basically your entire router configuration without any customers provisioned on it. Then we move on to day 2, which is actually customer or service configuration. And that was basically what Alan's talk was about. My presentation will cover mainly day 0 and day 1 configuration. And actually, kind of my last page in the presentation will cover what Alan spent 15 minutes talking about. So I think that's a pretty nice transition. So while we are waiting for the presentation to show up here, at least on my screen, I'm Jan. I'm from Nordlys, and I'm here to talk about how we were part of a merger between 2 companies and some requirements that was forced to approve this merger. So how far are we with the slides? Okay, right there, okay. Okay, I will try to do it without the slides for now. Yeah, you might have heard about Nordlys. We were formed back in 2019 by the merger of the 2 companies, Eni and Sydenergi. Sydenergi also holds the Stouffer brands, which is probably what is most familiar to most of you guys here. Through the merger, we would become both the largest fiber-to-the-home provider in Denmark, as well as the largest power utility company. Nordlys is basically a power utility company that have built a very large fiber-to-the-home business over the last 10 years or so. And to have such a large merger approved, a number of requirements was set forth. One was that on the service provider business, we were required to separate the service provider business and the infrastructure into different companies, different legal entities. In the same way that had happened, for instance, at TDC. It has also happened with the Danish power grid. And also basically the way that the Danish railroads work, where you have Banedanmark that owns the infrastructure, and then you have companies like DSB and Arriva providing services on top of that. Okay, still no slides. Also, we needed to be able to provide wholesale access to our entire network footprint by the end of 2020. Eni had already done that. We had not done that in Sydenergi. And now we have the slides. Cool. All right. I think I covered this already. Oh yeah, by the way, we also do DOCSIS, something that we kind of forget every now and then because everyone talks about fiber. But we are actually the 2nd largest DOCSIS provider in Denmark, and DOCSIS is internet over coax for those who don't know. Cool. Okay, to be able to have a structure where you have separated the infrastructure owner and the service provider, we need some way of doing business between those companies. So Eni had back in, I think, 2016 or 17, woo! They have set up this company called OpenNet, which is a broker platform that enables businesses between infrastructure owners and service providers. Basically, through a common API, the different infrastructure owners can expose their different addresses and different products they can sell on those addresses, and service providers can procure them. We can offer several service providers, several services on just one installation address. So, for instance, in a single home, you can actually have internet from, I don't know, New Day, TV from Nordlys, and maybe a kind of work from home service provided by a third supplier. OpenNet offers just 3 basic products, one aimed at the residential and SMB market, one aimed at the business and high-end, and finally, good old CATV or DVB-C. This is just to kind of set the idea on what this enabling of wholesale services is in the network. All right, so we are now in early 2020. the merger is kind of in progress. We are still waiting for the approval, and we need to do a lot of stuff. And we actually need to do it in just 10 months. We kept telling management, wait, this is kind of a big project. We really should be getting going now, and they kept pushing it. And finally, in February 2020, we got the go. Okay, we've had the kickoff meeting. We need to be done before Christmas. This is just a couple of 100 locations. We need to install new equipment. How hard can that be? Well, it was a pretty big task. The access network at that point was built purely on Cisco 4500s. And those who have been working with that know that they are probably not the greatest kid in the business if you want to do advanced services like providing multiple levels of quality as services, multiple levels of VLANs, multiple levels of multicast, for instance, on a single port. That box isn't really up for that. Also, it's coming to its end of life, I think, in 2025. Overall, I think we had a pretty mature network at that time. There was not a lot of stuff going on the fiber side. We had a well-proven design, mostly based on layer 2. Actually, some kind of scary large layer 2 rings, but let's not dive too much into that. I think Alan has already talked a lot about how provisioning of day 0 and day 1 of devices was back then. Basically, you looked up in your IPAM system or even in your Excel spreadsheet and found whatever resources you needed. You copy and paste the stuff into this text file, and you spun up PuTTY or whatever terminal program, plugged in your nice blue console cable, and pasted everything into the router. And then you sent it off to some technician that brought it into the pub, connected everything, and hoped it worked. And when it didn't work, you have to fight with this technician because he was missing a serial driver or didn't have a console cable or stuff like that. And well, often we didn't really get to upgrade the router before it was put into production. So it was maybe running a very old software with bugs or missing features. But when it was integrated, well, then we could load the software. Not really the best starting point for building a modern network. However, a few years earlier, we started another somewhat unrelated project to upgrade our DOCSIS network from 3.0 to 3.1. And for those that don't know about DOCSIS, a .1 upgrade, that seems like a checkbox kind of upgrade. It really isn't in any way. It means changing the entire underlay of how you do DOCSIS from using analog fibers from the central locations to the roadside copper into an IP underlay. Actually, very much the same transition that mobile networks went through when they switched from E1s and ATM to using IP-based transport in the RAN, which was something I think most people did at least 10, maybe 15 years ago. The very, very same architecture has actually been adopted by DOCSIS. To support that, we had developed a new network infrastructure because it is, since it was purely IP-based, it made sense to have things routed and not relying on layer 2. There was also some requirement to support multicast QS and stuff like that. So we have created a new 3-layer network infrastructure that we were going to build on. We had also designed a new out-of-band network, which I will cover in a later slide. The out-of-band network is an immense, important part of how we do zero-touch of new routers. It's basically, without the out-of-band network, we cannot bring up new devices. And the turn-off process include how we bring up an out-of-band network without anything on site, and we will come back to that. Okay. Yeah, I briefly mentioned the more than 200 locations. Actually, it was 270-something locations. Those are all locations where we have active equipment today, or we had back then. Mainly layer 2 equipment. But still, we went out with basically a complete new network in all these buildings, so it was very much a greenfield scenario. So we kind of didn't feel the pain that Alan felt when he was implementing automation. From the start, it was very clear that things should be done the exact same way across all locations, and we shouldn't care about, well, this pub is maybe 30% smaller than this one. Maybe we can buy a slightly cheaper router here. No. Everything has to be the same. If not, we have no chance of making this. It should be fully automated. All configurations should be built in an automatic way. We should do as little manual processes also to onboard the network into different systems. Also, we decided to go with PON as the access technology, both because we were already doing that in INI and also to work around some of the issues we saw with the Ethernet switches when it comes to modeling this quite complex level of services. For the transport of the services, which are all, by the way, layer 2 services, we went with EVPN, both since this is kind of the way you do things today, and also because it offers a lot of really nice features with regards to redundancy. You can use it to build both E-line and ELAN services, basically using the same technology. Capacity-wise, we went with 100G all over the place, and we reduced the size of the fiber rings significantly. So we didn't just went from 10 to 100G, but we also made the rings smaller, meaning an overall larger capacity in each area. The network, the out-of-band network we developed was pushed out across all locations and basically forming the ground for doing the day 0 and day 1 configuration. We had to bring in a lot of external technicians to run a project this large, meaning we could not rely really much on their skill set. We kind of expected them to be able to handle the screwdriver and connect the power the right way, maybe clean some fibers. But we could not assume anything with regards to knowledge about network equipment. Okay. For those of you who know Netbox, they can probably kind of recognize what's going on here. We had a few things kind of sitting around we could use. We had the overall network design, which was great. We had the out-of-band network design. And we had also been doing a little bit of day 2 automation during the DOCSIS rollout. We had NSO up and running, the same platform that Alan talked about, doing some very, very simple services. But we had no real source of truth. And I think for all of those who have been doing network automation, they know that source of truth is really the core of things. If you don't have a single place where you store information and you don't kind of duplicate them, then you'll have a really, really hard time doing things. And we had a lot of knowledge that we need to store in our source of truth. Not just the active components like the routers and switches, but also the entire PON network. PON is a shared network architecture, kind of like Ethernet in the old days, where you had the yellow cables where you put the taps in them and you had a number of workstations sharing as the same cable. More or less the same goes on here, except without the taps. Now we are working in the optical domain, and we have splitters where you put 32, 64, whatever amount of customers on a shared optical domain. And you allocate basically ports the same way that you do on a switch, just on the splitter. All of that is kept in Netbox as well. The overall idea was that we needed just 2 basic components to build a configuration, templates, mostly written in Jinja 2, and then the stuff in Netbox. And if we needed some things on top of that, well, then we did something wrong. To onboard each POP or each site into Netbox, we created a tool to do so no one should sit around and allocate prefixes and IP addresses. Basically just provide the things that cannot be automated, like the serial numbers of the different devices, which racks in the POP we need to go, etc. And also what kind of power was present in the POP. Some have AC, some have DC, some have both. And due to the chosen equipment, we actually needed both kinds of power. So sometimes we needed to install either an inverter to generate AC or a rectifier to generate DC. Having everything in Netbox means we could provide drawing and cable plans like this, hand out to the technician, so they could actually install everything in the correct location. So they didn't put maybe the patch panel at the bottom instead of at the top, or forgot a cable or something like that. So basically they knew that, okay, we need to bring along 11 single mode fibers and X number of DC and AC cables, etc., and connect everything up. And that worked tremendously great, which was really, really cool. Okay. think in the interest of time, I will just very briefly go through this slide. I think a lot of the stuff that we put in Netbox would be quite obvious to those who have been working with networks on a daily basis. But since we didn't just put the infrastructure there, but also the services we are going to deliver. So for instance, if we are delivering an OpenNet H1 service, we need to allocate 1 or 2 VLANs, and we also need to map that specific service to a specific POI or in an IA router. We have several locations where we can kind of exit traffic from our network, and some smaller service providers, they prefer to pick up everything at a single location, and some of the larger providers that has maybe a national network, they will pick up on a more regional basis. So for each POP and each service provider, we need to keep a mapping on where to deliver the service, and Netbox is also great for that. Another thing that became clear was have all our tooling as CLI tools. It's nice when you have been doing networking since the 90s and things. Linux or Unix is the greatest thing since sliced bread. But that's not really how your daily operation team thinks. They would like to have things kind of more in a GUI-like environment. And Netbox now have capabilities to put scripts and reporting right into Netbox. So instead of onboarding, say, a new device by running Python at router.py, now we can really do it just through the Netbox GUI. We can also run reports. For instance, our capacity planning people, they would like maybe a weekly report on the number of available ports on each location, so they can make sure that they order new equipment in time so we don't run out of ports. Okay, the out-of-band network. Out-of-band network, I think, is kind of like DNS was back in the 90s, something that people really didn't care about, but it's actually quite important. That was also the way we used to build the network, basically on whatever hardware we had sitting around. And we only had it in a number of larger locations. But we had already learned from the DOCSIS project that having out-of-band everywhere is a really, really nice tool. Both having access to console servers everywhere and also having a management port that doesn't rely on the underlying network. So we built actually a completely separate network covering more or less entire Denmark with hundreds and hundreds of routers and switches as a full MPLS network, running OSPF as an IGP, LDP, BGP on the top, and with several layer 3 VPNs provisioned so we could separate router management from access control, ventilation, etc. Because they are managed in quite different ways, they are also managed by different entities. From the beginning, it was very important that we didn't rely on the production network being up. Basically, in case something catastrophic happens to the production network, we should be able to access and use the out-of-band network anyway. We do use a few links in the transport network, in the optical network, but again, no matter how catastrophic failure you will see in your IP network, it will not affect the transport network. We decided to put LTE or 4G in each and every router, which has quite a number of nice features. First of all, it means you can actually bring up your network even if you don't have fibers ready, because it will kind of boot up using 4G, and you can connect the fibers afterwards. It also means that you can extend your out-of-band network into locations where you do not have fiber. That could be if you go into a third-party data center for peering, for instance. It can be quite costly to get additional fiber in there. Some data centers provide services like this where you can kind of rent an out-of-band port. Some don't. We also, especially for the coax network, has quite a lot of presence outside of the Norlys fiber footprint, where we again have limited fiber. So we have a few sites running on purely 4G. The overall idea, again, is it should be extremely easy to bring up new equipment and replace old equipment that has failed. So this is just a look on what we actually put in the networks. On the top, we have the power. We have 2 PDUs, one running on no break, one running on utility power. Then we have the out-of-band here with the Cisco router and the switch and a panel to break out all of the console server ports. Here we have the PE routers. It's the Cisco NCS 5500. Since this is a purely AC side, we have a rectifier here to provide 48 volts for the DPON OLT sitting here in the bottom. So let's move on to the day 0 and the day 1 part and how we bring up things. Oh, let's first look at the hardware. Just to give you an idea on the sheer amount of hardware. This is equipment for 15 POPs, and we had 270. And this is just actually the active part of the equipment. So on top of that came all of the PDUs, all of the cables, all of the different stuff that needed to go in the rack to manage cables, etc. Very fortunately, this was before COVID and the current supply chain issues, because if we had tried to do this a year ago, I won't be standing here today talking about that we managed to do things in time. Okay. Bringing up things. As you could probably see, the majority of these devices are from Cisco, but unfortunately, Cisco has, of course, implemented different ways to do this on iOS and on iOS XR. But let's start with iOS, which is what is used for the out-of-band network. They implement a protocol called PNP. I think it just means plug and play. Which is an HTTP-based protocol where you encode messages in XML, and the router kind of calls home on a regular basis and asks if there's any work to be done, and the PNP server will let the router know if it should do something. The PNP server, I think, can be procured from Cisco. I'm sure it can. We decided to implement our own as a Flask application, so that's written in Python. And that is running, of course, on-prem. If you bring up a new device using 4G only, we cannot provide the DHCP options to the router to tell about the server. So it has a built-in feature where it will try to contact Cisco. Cisco has kind of a cloud service that will, based on the serial number, allow you to redirect back to your own server. So that's how you kind of get started with a 4G connected router. And then it will just went through a number of steps. First, we will check the software version, something that is stored in Netbox. So if the router reports a wrong version, we will initiate a software upgrade. But that's done. Since this is a Cisco product, we need to turn on a number of licenses for everything to work. And then we can move on and obtain the configuration, load it into the router, and finally onboard it into NSO. And to follow along on what's going on, we are reporting the progress into a channel in Teams. So our operational staff can kind of keep a track on what's going on. For instance, when a technician starts to bring up a new router in the POP, he or she doesn't really need to call the team and saying, okay, now we are starting this, we can see it in Teams. So XR is working in a kind of completely different way, but looking more like what you will see when trying to bring up a server. At this point, we have always the out-of-band network up and running, so we can purely rely on DHCP. When you turn on the router, it will issue a DHCP request with a number of custom options, and one of those would indicate that it wants to initiate an iPXE boot. So we return a URL, and it will download the software. So the router will, from the first attempt, be loaded with the correct software. When it's up and running, it will issue an additional DHCP request, now with some different options, telling it wants to start to do CTP, which means zero-touch provisioning. And it will get another URL pointing to a Python script. It will download into the router and start to do a number of tasks. For instance, generating SSH keys, local user accounts, downloading the configuration file that is going to apply it in a later step, and also a second stage CTP script. And why we need to download things now is because to install the software and have it activate, the router will reboot again. And that is kind of a way around keeping state on how far we are. The software is packaged up as something called a golden ISO, which is the way Cisco is now distributing software for XR, where you can package everything together, the base XR system, as well as the various packages. And you can also make sure you have the right smooth patches applied, so you don't have to add them afterwards. You can also package up optionally a configuration file if you want that. So basically your day 0 configuration you can bake into the golden ISO. The configuration is built very much like what we saw with the PnP server, another Flask application working off the serial number of the router, a bunch of Jinja templates. But since we need to support quite a few different configurations, for instance, kind of small P router, large P router, LSR router, peering router, etc., we are relying on the roles, which is part of Netbox, to choose the correct templates and build the correct configuration, including the interface-specific configuration. So we make sure that interfaces facing the core are enabled with LDP, MPLS, multicast, whatever is needed. Yeah, and this is the slide that is basically half of Alan's presentation. You can even recognize NSO. So we have OpenNet sitting on top here, who places orders into our BSS system. And from there, we talk to a system developed in-house called NextGen. I think on Alan's page, it was called orchestration something. It is kind of a provisioning broker with the idea that the BSS system should not be aware of what's down here. It should even be aware if a provisioning should go to this network or maybe another network over here, maybe using a different system than NSO, which is also why the single source of truth to Netbox is done on this level and not here, because then we could have something that is not NSO sitting out here and still relying on the same single source of truth. Again, as Alan mentioned, NSO is running based off Yang models that in a kind of technology-neutral way describe the service and can provision a service across multiple devices in a somewhat atomic fashion, meaning that if you have a service running across maybe a Nokia OLT, Juniper router, and a Cisco NNI, a POI router, if the configuration fails at some part of the process, it will roll back everything. So it will not leave your network in an unknown state. It can even kind of emulate rollbacks on devices that does not support rollback, like Cisco iOS. So coming up to the last slide, we made it before Christmas, which is why I think we should have the small Christmas tree sitting on top. Actually, already in October of 2020, we onboarded kind of the first test service provider on part of the footprint. So meaning in about 7 or 8 months, we had the first part of the network up and running, ready for test. And what we have seen is not just that we made it in time, which is of course great, but also that we have seen a significant reduction in errors. And that is really seen from my side, the great takeaway of this project is not that we made this specific project in time, but basically everything gets more or less installed in the correct way now. Things are connected where we expect it to be connected. We don't have issues where people try to bring up a new link and forget to enable LDP or something annoying like that. We have not seen a single IP that was by mistake reused for something since we have started having Netbox as a source of truth. And again, as those of you have tried to be on call Saturday afternoon, sitting with a guy on the other side of the country that didn't have PuTTY, that didn't have the serial drivers, on a company laptop that was locked down, not allowing installation of drivers, and trying to guide someone through that, having access to the console server everywhere is just really, really great. When a box breaks down, we go into Netbox, change the serial number to the new box, the technician plugs it in, turn it on, it will be brought up with the right software, the right configuration. This has actually been so successful that we are now deploying this into other networks. I don't remember if I mentioned in the beginning, but at top I'm running our own network. We do run a few other fiber to the home networks in Denmark. And some of these networks has adopted the same platform that we have developed. We have also adopted Netbox as a source of truth for the brownfield network. We are not completely done. And I think some of the things Alan mentioned probably tells why we are not there yet. But we are very much working on this. And to this day, we can keep on removing manual processes. And really no one has lost their job because of this. They have just probably found more exciting things to do. Okay, this was the last slide from my side. I have honestly no idea on how we are doing with time, if we have time for questions. Okay, one question. No, it's just the... Okay, I think maybe that meant one. Okay, so we might even have time for 2 questions.
For a great talk. It was interesting to see that you made this work in so short time. That's really impressive. And it also seems like there are a lot of moving parts in this environment. And I'm sure, given the success, that this is something that you want to keep continuing on developing and maintaining. And now I actually forgot my original question. Yeah, so let's just make this a comment. Thank you.
Thank you. Much appreciated. Thank you.
Sorry for being a bit far away. Hi, Matthias Kronjäger from Cisco Systems. Yeah, thank you for the amazing talk. It was really interesting. I'm curious, given that you've told this story about starting from not having a lot of automation and ending up with everything being great and automated, from a personal perspective, I'd be quite interesting. Were there things that initially you really wanted to do or had on the drawing board and was in your plans for this system that once you actually had to do it and start building it, realized, you know what, that's too difficult, or we're going to have to do it some other ways? Basically, are there some learnings and takeaways if someone else wants to do something similar?
Yeah, first of all, thank you for the question, and sorry for bashing your platform. Yeah, and you actually, your question can let me move on to bash another platform, and that is the Nokia OLT. Because actually, from the beginning, we had actually an idea that we could do at least some kind of automation on that platform as well. But it seems that Nokia really wants you to connect a console cable, or sit down and write your configuration and put it on a flash card and send someone out and put it into the device. So we would really love to have been able to do something with the Nokia platform. And I think we even briefly at some point considered some kind of CLI scraping using the console port. But I'm somewhat happy that we did not do that. Also because the Nokia devices, they have quite large configuration files. And I'm sure no one of the vendors will be buying me beer at the bar anymore.
Hi there, Clay Haynes, Twitter. One of the questions that I had was, since you had the provisioning server available from like public LTE networks, how did you make sure it stayed safe and secure and that no one could actually grab your configs or do anything nasty? Yeah, that's quite a good question. Well, first of all, of course, you need to know the serial number. And the second is that, well, yeah, theoretically, you could get part of the configuration, but then we move on to additional steps in the configuration where we start to assign IPs and need to bring up IPsec connection, etc. And I think it would probably stop there. Another thing that we definitely did consider, but couldn't do, for instance, due to time constraints, was using what is known as an enterprise or private APN in the mobile network. Something we very much did consider, but we could not do that in time. Traditionally, it takes a long time to bring up such a service. I did personally used to work at a mobile provider, and I really love that product, but I also know from experience it takes a lot of time to bring up. Because that would be by far the best way to do it. Okay. All right, if you come up with additional questions, we are quite a few people here from Norlys, both today and tomorrow. Come find us in the break or at the social tonight. And actually, I just want to plug a small thing about the company, because those who have been here for a long time, you always have a tremendously hungover Friday morning. And there used to just be coffee. So this year, Nordisk will be sponsoring sweets and salty snacks for the morning session when you all hang out tomorrow.
Well, thank you to Jan. We already gave him an applause. We are now at the point of one of the most important parts of the program. Yeah. So we have a bit of a coffee break now, and we will be back in. We will ring the bell when we are ready for you to come in again. So go out, have fun. See you guys. De lytter ikke alligevel. Jeg kan godt tage den op til frokost, så skifter vi bare. Og det er et godt spørgsmål. Hvor er ligger min frokost? Jeg har ikke fået lagt den derude. Jeg har lagt den på JC og alle de andre steder. Jeg tænkte også, når han spurgte. They asked like, where's the YouTube link on the website? Of course, it's there in a minute. Should we see if we could perhaps close the blinds over there? But I think we just need that one, right? Yes, I mean then. How did it go? Kan du tro? Ja, ja. Den vej over, ja. Jeg tager alle de gange. Det gik da meget godt. DKNOG12, hvad er det for noget?
Ladies and gentlemen, the conference will start in a few minutes. Please take your seats in the plenary. Ladies and gentlemen, the conference will start in a few minutes. Please take your seats in the plenary. Ladies and gentlemen, the conference will start in a few minutes. Please take your seats in the plenary. Ladies and gentlemen, the conference will begin shortly. Please take your seats in the plenary. Ladies and gentlemen, the conference will begin shortly. Please take your seats in the plenary. Ladies and gentlemen, the conference will begin shortly. Please take your seats in the plenary.
Welcome back, everybody, even the latecomers. I'm Fergus Mackay. I work for Flex Optics. We're a sponsor. I'm one of the program committee, and I'm chairing this section. Next up, we have Johan Bach from Infinera, who's going to talk about XR optics, which are really good.
Thank you.
Over to you.
Thank you very much. Hey. What a crowd. Great to be here in sunny Copenhagen. And you even have a, speaking of greenfield, I listened to Alan's talk earlier, greenfield and brownfield. Sweden is still quite brown. We don't have green grass yet. So it's nice to be here for many reasons. My name is Johan Bäck. I've been with Infinera for over 20 years. I started my career in handling indium phosphide wafers back in our clean room in California, and now I handle customers and these types of dialogues. So quite different. We're speaking to the vertical integration. Let's see right here if this works. So, a little bit about Infinera. We're all about dense wavelength division multiplexing and optical transport. So, addressing use cases from subsea cables, putting a lot of capacity, from the US to Europe, for example, long-haul metro, and into the access. We're about 3,000 employees worldwide, very vertically integrated. If you look at the technologies in our products, they're like the underlying technology is based on photonic integrated circuits, something we pioneered 20 years ago. That's how Infinera was founded. Indium phosphide, nobody thought we could do it. Here we are 20 years later, and photonic integration is a key aspect of all optical transmission to date. We build our own coherent ASICs. I'll talk a little bit about coherent today. It's really just doing what people in microwave have been doing for 35 years. It's just that optics, everything is much, much faster, about 10,000 higher symbol rates. But it's something we're doing. We do our own packaging, and we build our own systems that we sell to ICPs and service providers and ISPs globally, and wrap services around it. So I'm going to talk about a couple of trends. The first one is optical transmission is really going coherent. We saw that about, 2010 or so, the first coherent transceivers came out on the market for long haul purely. And the whole idea there with coherent is that you could get a lot more capacity on a single fiber. So at the time we were selling at Infinera 160 times 10 gig, so 1.6 terabits on a fiber pair. With coherent today, the evolution we've had, we're up to, 30, 50, 80 terabits on a fiber pair. So it's really been crazy, the type of evolution over the past decade. So starting in long haul, then it went into metro networks, so smaller networks, not tens of terabits in scale. And now what we're seeing is a trend where coherent, especially with XR optics, is a new technology we're productizing this year. We're looking at how coherent can drive further out in the networks into the access. And of course, this is driven by increase in traffic everywhere. And coherent is like the next step once you run out of steam with on-off keyed solutions. And the challenge is to make things simple, cheap, because in the access, things need to be simple and cheap, right? And large volumes. So I wanted to show in a slide here what coherent transmission does. So starting from the left, this is about 2015 or so. The first 200 gig transceivers came on the market. They could do 100 or 200 gig on a fiber pair, go up to maybe 1,400 kilometers in the highest rate mode, 200 gig. And then there's just been a succession of new generations fueled by two things. One is better ASIC technology, lower line widths in the DSPs, meaning you can do more and more fancy processing in the same power envelope. And the second thing is just utilizing higher and higher order modulation formats, and that's possible by better forward error correction and a lot of complex things I won't go into here. So if you look today at the latest and greatest 800 gig technology that's on the market, we can drive 800 gig wavelengths over 1,000 kilometers in real networks. We do that today with those products are available. So you may wonder, coherent, why would anyone want a coherent transponder, right? Because these days it's a lot about pluggables. And yes, that's true. But there's one big difference between an optical transponder that's like a standalone optical transport device, and a pluggable that you can literally stick into almost anything needing, even your toaster, hopefully one day. And that's that the latest transponders, they're running 800 gig per wavelength because they're really like Rolls Royces or, Ferraris. No limits on, it's all about performance. Pluggables have to fit in a small space and fit within a certain power envelope. So the latest pluggables are running 400 gig per wavelength. So what you're giving up is really two things. You're giving up on reach, how far you can go without regenerating, and you're giving up on cost per bit in some cases, right? and how much capacity you can get on a single fiber. The other trend that's happening is, wherever you look in telecoms or datacom, like open networking is here, even at the the basement of telecoms, which is DWDM. So starting from the bottom, we have a line system that's basically amplifiers to make sure that you have the right power level coming into each receiver, so you can terminate the traffic. And it's also multiplexers, you can call it, or ways to route traffic and also separate it into multiple interfaces. And those line systems today, it's table stakes to sell an open line system that can carry traffic from multiple different types of transceivers and transponders. And the transport layer, which is layer 1, you have an optical engine, so that's some type of optical function to convert bits into photons, electrons to photons, and a DSP. And those come in two forms. The first one is pluggable. So here's an example of what that may look like, QSFP-DD. The other one is embedded, which is also a module. It's just, you can't just plug it into something. It's bigger and it sits on a board. It uses a lot more power. And there are different types of transport devices, right, that you can buy if you want to go far or have a demarcation. But increasingly what's happening is also pluggable optics. You can stick them directly in routers and switches, and it's not just routers and switches. With XR optics, we're looking at access applications and for example, the O-RAN ecosystem. So radio vendors, right? The radio unit could have a coherent interface down the line for next generation fronthaul traffic to run. It could be virtual DUs. You have like an x86 server stack with some type of smart NIC that now come with QSFP-DD cages. You could put a coherent interface right there and build networks in a fundamentally very different way. And at Infinera, right, we've been building very closed systems historically. So when I started as I think of myself as young still, but I realize I'm not, because when I started at Infinera, we were productizing, which was like this fantastic new product. We were so proud. 2004, it looked like a fridge. It was 400 gig of DWDM capacity, had built-in OTN switching, and it sold like hotcakes. I think 2007 to 2008, 10 gig long-haul wavelengths, we had majority market share globally. Okay, so wonderful product, but these days, 400 gig of capacity is this size, right? So it's gone from something like this to something like this. And we've gone from selling something quite closed, so monolithic system that you could use, you bought a chassis, it did everything, and you could hook it up into something, to living in this open world where this XR optic, it's our first pluggable optic. We will keep making transponders and embedded optics. We're very successful with our CHM6 for subsea. But unless you need 800 gig on a wavelength or 30 terabits across a long-haul network or a subsea cable, there may be places in your network for coherent pluggables like XR. Like XR or ZR+. So XR optics, we're utilizing a feature called Nyquist subcarriers. And if you're familiar with radio technology, this isn't really rocket science. What we're doing is we take one laser and we, instead of having one large carrier, we split into many smaller carriers. So this is done in 5G new radio RANs, for example. But we just do it at a much, much higher rate. So 192 terahertz is roughly the middle of the C-band. So it takes a lot of DSP power to do this. We do it to extend reach in subsea and long-haul applications. But with XR optics, we're doing something different. So each of these subcarriers is framed independently. So you can run we have 16 subcarriers in this 400 gig DD. Each one can carry 25 gig of traffic. It's like a 25 gig E. And they're really like virtual wavelengths. You have one transceiver, but you can go to 16 different endpoints. So a different way you can call this is like, it's next generation coherent PON, passive optical networking. So while the rest of the world is struggling on how to get beyond 25 gig PON or 50 gig PON, we have 200 gig PON here today in my hand. And that's one use case we're talking. I'll talk more about that shortly. All done by these subcarriers. So if you have a long haul system, this is an example from using our transponders with Nyquist subcarriers. You get this spectrum of wavelengths that's really, really filled of traffic, right? So we've done 30 terabits from on this Maria cable and deployed 29, and that's really, really good, very, very competitive, high spectral efficiency, and allows an operator to use that fiber, subsea fiber, much, much more efficiently. I don't know what it costs to lay a subsea cable, but it's probably, I don't know, it's at least $100 million US. But even if you want to go from here in Copenhagen up to Stockholm, you know, buying a fiber pair, an IRU may cost €1 million. So if you make that investment, you may want to consider, it depends, right, on what type of traffic you need to run. But transponders have their place because fibers are expensive. So now I'll get into this point-to-multipoint function of the XR optic that's enabled by these subcarriers. So in any aggregation network, and that could be a metro network or access network, basically where you have a lot of smaller sites on the left there, and you take traffic from those smaller sites into a larger core site. When you use traditional point-to-point optical transceivers, if you have 10 smaller sites and you need to take traffic from 10 smaller sites into a large site, you need 10 small transceivers. So you end up with 20 transceivers. With XR, we can really collapse that and have one large transceiver at the hub talking to those 10 smaller transceivers at the edge locations. And this can save a lot of money. So we can reduce the amount of transceivers. We can eliminate, in some cases, intermediate aggregation devices. So if you have, it could be a switch, muxponder could even be if you have a router that's basically not anchoring services, but aggregating a lot of low-speed interfaces to high-speed interfaces. You can improve the router efficiency by, for example, using a 400 gigabit Ethernet port and talk to many smaller devices. So you could have a bunch of 100 gig Ethernet ports in your access sites talking to a single 400 gig E-port in your hub site. So you can use your equipment more efficiently and save a lot of money that way. So I'll bring up one example here from, before the example. After this, we'll have a speaker from Smart Optics. At Infinera, we think this is a very smart optic because it does so many different things. It can work in point-to-point. You can also use this as a breakout cable. So like I talked about this 400 gig router port, right? You can configure that to 400 gig Emax, right? This all of a sudden becomes not a 2-kilometer breakout plug. It's 1,000 kilometers if you build the right line system. So you can go from a single 400 gig port out into 4 different sites. That can be up to 1,000 kilometers away, but just a couple of hundred is perfect. We also have this flexible point-to-multipoint mode where we can do some switching inside the plug, VLAN switching to reach up to 16 different endpoints and kind of reassign traffic in a very dynamic fashion. Is very important in access use cases. And using this point-to-multipoint function, you can reduce the amount of transceivers. We've done a lot of case studies with some public, with operators worldwide for the last 2-3 years. You get flexibility. We can deploy on single fiber, for example. We can deploy in different types of infrastructures, different channel plans, etc., and move capacity around even asymmetrically, so you have higher downlink and uplink speeds. So very, very flexible and future-proof. We can address all the usual ZR, ZR+, use cases, unamplified, amplified, or extended reach links, but also a lot of new ones with a point-to-multipoint function, right? We have access applications and metro aggregation. I'll talk a couple of minutes about this study we did with BT. We took their nationwide footprint a couple of years ago, looked at about 1,000 of their central offices where they have traffic on the order of, I don't know, 20, 30 gig that they need to take into core sites. And the traffic flow is really aggregation, right? Hub and spoke. And we showed really significant savings, over 70%, using XR optics for point-to-multipoint compared to traditional layer 1, layer 0 solution. We're also looking at access applications, as I mentioned earlier. So, for example, 5G front haul. There are, for example, tower owners who, like we did a trial with American Tower last year that we did a press release on, where we tested to run XR to multiple cell sites. And American Tower, they own 250,000 cell sites worldwide, and they see their tenants needing to transport a lot of capacity back to central hub facilities where they have the DUs. So being able to leverage fiber in the ground, PON infrastructure to deliver 5G front haul services is really appetizing. Could also be, services ISPs may be interested in delivering more capacity over existing fiber out to enterprises. So lots of activity there. Happy to talk in the break more. I guess I missed those animations. All right, so you may wonder, so XR, is this only Infinera who's going to be pushing this or selling this? Is it a bespoke technology that nobody else will offer? And as I said earlier, Infinera, our strategy now is to be open. So we created an MSA working group last year together with BT, Verizon, Lumen, Windstream, and Liberty Global. We've added some more members since then: Telefonica, Zayo, Crown Castle, Colt, AT&T. So we have a wide group of different operators with interest in different use cases, from the core all the way out to the access. There's a pipeline of other network equipment manufacturers about to join, so this won't just be operator-led. There will also be others joining, and the goal really here is to create an ecosystem, which is, in our view, very, very important to create differentiated, overall solutions for you as a customer, where each vendor contributes what they're strong at, right? So takeaways: point-to-multipoint could be a different way of building networks. You can save on the amount of transceivers, the amount of router ports, can use higher speed ports to aggregate traffic from many endpoints, reduce CapEx and OpEx. You run this in many, many modes, right? So point-to-point, maybe 400 gig to 400 gig core router interconnect, out to the access where you do 5G front haul from many cell towers into a single edge compute facility. So I think that was my last slide. If you have any more questions, please come to the booth. I'll be over in the iTectra booth with this thing and a little photonic integrated circuit you could take a look at. So thank you very much for your attention, and open to questions here if you have any.
Thank you, Johan. So I know one person who has a question. Okay.
When is lunch? Was that your question?
No, you've got to sit through someone else first, I'm afraid. Any questions from anyone else? None, really?
You just bought all that, didn't you? All right, I'll be outside later. So. Yeah.
So I hope I will, oh yeah, Peter Krüppel from Progressive. I hope I will not embarrass myself by asking this question, but what exactly does coherent mean?
Yeah, so coherent means like old school light communication, right? You take a light source like a laser and you turn it on and off. That's called intensity modulation, on-off keying. And if the light is on, it's a 1 or a 0. With coherent technology, you start playing with not only the intensity of the light, which could be multiple levels, but you also modulate the the phase. So you could, it's similar to, yeah, hey, actually someone at Infinera knows this. So you know, like AM and FM radio. FM isn't quite phase modulation. Like phase modulation is like a digital version of FM, but you can view it as AM and FM radio combined. Instead of just having things on and off, there's a lot more sophistication going on. So you can get every time you turn that light on and off with the old school transceiver, that's called the symbol rate, right? You can do that, for example, 50 million times per second or so. Every time you have one of those symbols with coherent, you can send a lot more bits. So it's a more efficient way of getting information across a fiber. And it's not, coherent it's been done in microwave for years. The interesting thing now is that there's actually something called Shannon's limit, where a guy called Claude Shannon at Bell Labs, I think in the, 40s or 50s or so, he wrote something on a napkin almost like, here's the limit of how much capacity you can send across a given channel under a certain amount of noise. And the radio guys, I think they've been there for years. And at optics, with the latest embedded optics, the for subsea, that's it. There won't be many, you can't get more information across that. So it's an interesting time to be in optics, and actually very happy to be here. Most of you are not in optics, so happy to have your attention for such a long time. Good question.
There's nothing like, there are no bad questions. Just because you don't know doesn't mean that everybody else knows. So, any more good questions? Last call? You're not going to get your lunch any quicker if you don't have questions. Just saying. We have...
Hi, my name is Harm Werkman. What is the optical power budget of your XR optics? What's the output power and the input power requirements?
Yeah, so output power, we do 0 dBm, whether it's QSFP DD or CFP2, which are the two form factors we're bringing to market this year. There are also some other optical specs that we're quite competitive at to make it easier to work in a brownfield environment. Now I got to say brownfield again. And on the input, like what we're targeting as a spec, general requirement for PONs is to go 30 dB. So that's the spec we're targeting for PON applications. Like more like a metro application, it's less relevant because the line system will make sure you get enough power to terminate the signal.
Any more questions? We like good questions. Oh.
So I'm Tom from Cloudflare. I was wondering if there's any work being done in getting closer channels when you're looking at the available frequency space that you can use on optics, because I think currently the separation is 100 gigahertz. Is there anything like kind of being done there to get that even closer and closer together to get more capacity out of a fiber?
Yeah, so that's been an evolution for a long time. I showed that spectrum. You can see things are very, very tight. I'll put it two ways. So everyone's trying to get the channels closer together, and it's been done with something called flex grid, where you have these, the WSSs, for example, so you can support down to 37.5 gig spacing. With these Nyquist subcarriers that I talked about, we have actually these 25 gig independent channels, and this channel spacing is less than 100 megahertz. So there's insanely tightly spaced, and there are some control loops to make sure that things work not just downstream but upstream. Then if you have two of these sitting next to each other, they still have to be, I don't know, 6-8 gigahertz apart. But if you want to route them to different locations, you're limited by the WSS technology or optical filtering technology, which is much coarser in comparison, like, I don't know, 10, 15 gigahertz. So yeah, it's all about, especially on subsea, it's all about how much can you get into the link. But in metro and access, it's less critical. All right, so it's time for Kent, I think, or?
Oh, another
one, yeah.
Hi, Steve Jones from Huber and Suna. Just to answer the question earlier about closer. Just to answer the question, yeah, you can get 50 gigahertz spaced DWDM. You typically use them for 80 channel muxes. They're available today. Most people provide 50 gigahertz spaced DWDM across 80 channel muxes.
Yeah, that's right. Good.
And another one.
I shall project. Matthias from Cisco again. I just wanted to say, I looked it up. Mathematical Theory of Information by Shannon was published in 1949.
And what did I say? I said 40s or 50s?
40s or 50s.
Yeah, all right. Yeah. Wonderful. Yes.
And actually, if anyone's curious, it's a fantastic read.
Yeah.
Maths is not that hard.
People, please do use the mic, because we have a lot of people watching, and if you don't use the mic, they don't get to join in all the good bits. So, any other more comments or questions or? Great. Well, thank you very much.
Thank you all. And over to. Oh, thank you. Thank you very much.
Okay, next up is Kent Lidstrom.
So, yeah.
Hi, Kent. Welcome. Kent is going to talk about open DWDM in the metro area. And do we have slides? Not yet. Okay. Try speaking.
And third time's the charm, right?
Good morning, everybody. My name is Kent Lidström. I'm going to be here talking to you about optics. So I'm going to repeat what Johan just said, but from a slightly different angle. I'm also, very much like Johan, a very young guy that's been in the industry for at least over 20 years. I'm working for Smart Optics today, and we are a Scandinavian manufacturer, and we develop and manufacture open optical line system, and we do sell that together with optics as well. So what I'm going to talk about here is the DWDM solutions in the metro and some aspects around that. I'm not going to talk as technical as Johan did related to the technology, more on our experience of how this works into your environment if you're going to run the optics in a router and switch, and how to relate to the open standards that are applicable now in the market. So the two topics that I will talk about here is, which one? That one, I guess. Related to the 400 gig technology and what trends we see there, and what kind of challenges and opportunities you guys can benefit from when it comes to this technology. The second point is around disaggregation. Why is this popular? What does it mean? And most importantly, what kind of challenges and opportunities does it bring for you? Starting with the 400 gig side. What I will do here, I will talk about the pluggable 400 gig optics that are now coming out on the market. It is a very, I would say, exciting technology that will change the dynamic on optics and how you use optics in the metro and access networks. If we look at an open line system, some kind of transport network sitting in the middle there, it could be point-to-point, ROADM-based, I don't really care in this case. You can use the pluggable optics in two ways. One way is if I call it the traditional way, where you put pluggable optics into your transponder, muxponder, you get certain capabilities out of that. The typical form factor for that right now is CFP2. This is very applicable still for the 400 gig pluggable optics. However, this is not what I'm going to talk about. If you have specific questions about this, talk to your DWM supplier and you will get more information of, say, technology, performance, and so on. What I will focus on is the IP over DWDM, where you plug in the 400 gig optics directly into your host environment, the switch and router. And our learnings so far and our experience, how this works, it is to some extent quite simple, but there are also a lot of challenges associated with it. Looking at it from a technology standpoint then, we have buzzwords on the market, 400ZR versus the 400ZR+. What does it mean? 400ZR is a very well-defined standard, standardized by OEF. It specifies all the aspects of the optical modules. It specifies it on the optical level. That means you are supposed to be able to take vendor A on one side, vendor B on one side, run traffic toward each other, and it should work. And it does. It is standardized on the electrical interface. That means if you've qualified in your router supplier A, you are supposed to be able to take supplier B's transceiver, plug in into your router, and it should come up and it should be able to talk to it. And last but not least, it's also standardized on the register map. So all the information that you read from one module will also be presented in a different module. So that means you can basically commoditize the 400 gig optics. This really works well. So we've tested the OEF 400 gig on, I would say, all the major switch and router suppliers. Very successful results. There are some deviations. I mean, if you look at, for example, a Cisco portfolio, they have multiple platforms that support 400 gig, the pluggable optics. Some does not. We, for example, tested a Nexus platform here this week, and the original software that was released did not support it. But then the latest patch that was released here just recently did support it. So there are a lot of improvements going on in the overall industry to support the different optics. But in general, this works quite well. If we then compare it to the 400ZR, what is that? Well, 400ZR is not a standard. People talk about it in different aspects. There are a number of different MSAs that are falling under the umbrella of 400ZR+. I point out a few of them here, the OpenXR that Johan just talked about. We have the Open ROADM, and we have the OpenZR+ initiative. All of those are in different, say, development cycles with different aspects and feature sets. There are also a number of proprietary versions of those that are not falling under an open initiative, but that can provide advantages for the network. When you use those, they are supposed to be able to work in many different applications. Everything from simple point-to-point, longer distances, ROADM-based networks. There are some challenges associated with it now, day one. But if we look at the 400ZR+ and our experience there, what we see is that it's clearly something that you need to have, say, implemented into the host system. It is only the OpenZR+ that is GA today with optics that fits into switch and router, meaning the OSFP or SFP or QSFP DD form factor. There are CFP2s that fulfill the Open ROADM spec, but no GA product today that fulfill the Open ROADM spec on the DD form factor. They will come out later this year, but not yet. You cannot expect that if your router supplier have implemented support for OpenZR+ from vendor A, that vendor B will work. So far, we have not been very successful there. You need to have say, host implementation for that particular supplier of the optics. So this is, of course, a challenge, but it's also an opportunity because this allows for innovation. Under the ZR+, you can actually add more benefits and add, if I call it, functionality that enhances your network performance. So there are pros and cons with everything, but this is one of the challenges around it. And if we look how those optics are supposed to work, I'm going to show you a table here. I'm not going to go through every detail, so don't worry. But if we look at the way one of those optics is working, is a 400 gig optics, they have a 12-byte area in the register map where they expose their own capability, called different application modes. On an OpenZR+, there are 14 different defined versions of say, capabilities. The first 3, application mode 1, 2, and 3, they all belong to the OEF 400ZR standard. When you use them, it will work very well. The remaining ones, they are associated with the OpenZR Plus in this particular case, then they will work slightly differently. So this is what I mean when the implementation on the host side is very well defined. It is well defined for the first 3. For the remaining application mode, it varies from supplier to supplier. The way this is supposed to work is that when you plug it in a switch and router, it reads the capability from the optics. And if the router supplier have implemented support for different application mode, the user gets an opportunity to configure the optics in the way that they want them to be configured. So it's a very smart way of doing it. I wish everyone followed the same standard, then it would be much easier, but that's always the problem with standards and deviating from standards. So that's, of course, the most common one, where you run it in a router, you have a 400 gig with CFEC. That's the original OEF-based standard. Another flavor that is also commonly used today in the switches and routers are the application mode 5, where you run it in 400 gig mode. Everything looks identical on the electrical side, but we use the OFEC instead of the CFEC. So we get significantly better optical performances. So now all of a sudden you can go in a fairly large, metro network with several hundred kilometers of transmission. So that's, of course, a very compelling application mode. Cisco, buying Acacia, they have a very good and mature implementation of this. But in general, what we've seen is that that mode is working quite well in the majority of the routers today. Some of the other modes that could also be of interest, running, for example, this one, 4 by 100 gig over a 400 gig line. Why is this of interest? The router has a 400 gig native interface. Why do you want to divide it into 4 by 100? Well, it provides an excellent migration plan. Because what you can do here now is that you can start to utilize the, if you build a network very similar to what Johan explained, you have 400 gig capable routers sitting in your head-end side or a central office, and you have 100 gig capable routers further out in your network. You can put a simple layer 1 muxponder and terminate that into a router port. That means the most expensive part of that muxponder using your QCP-DD on the line side, that will be the optics itself. Once you then upgrade your network in the access or further out to a 400 gig capable unit, then you just move that optics and put it into your router. So that migration plan becomes extremely compelling. But other reasons for it, if you go down in line rate, so in those different application modes here at the bottom, we go down to, for example, 300 gig on the line side using 3 by 100. That one, of course, allows better performance. I will show that a little bit later. So that's one of the reasons why those are, I would say, important. Very few of the router suppliers have implemented support for this today, so that's on their roadmap. But the only thing that I've seen that works properly, it's actually Cisco implementation of the later ones used in more muxponder modes. So, but I expect everyone else to follow going forward, because I think this really makes a big difference for those used in over more advanced networks. There are some challenges around this. The standard today specifies -10 dBm as the TX power level. That means they will be very difficult to fit into a brownfield network. So in order to get them into a brownfield network, you need to have units with higher TX power. Those will come out and be GA end of this year, so we start to see an evolution toward optics that actually deviates from the standard, but in a good way, providing higher TX power, so we can actually bridge longer distances and also fit them into more of a brownfield network. If we look at a different, say, market forecast for them, we see that the deployment expectation between coherent in, as a transponder, muxponder, proprietary version in the embedded version that Johan mentioned, versus IP over DWM, they grow pretty much at the same rate. We will see in the end there later on, the expectation is to have about half in 2026 expectation is about 500,000 deployed units of both types. So it is clearly a technology where the analysts expect a lot of growth. So very interesting technology. So that was my last slide around the 400 gig side. If we then look at the disaggregated part of the network, so this is then another important building blocks to put together an open line system running IP over DWDM. So what is disaggregated open optical solutions? Well, it depends a little bit who you ask. I will provide my view on it. If we look at the left side there, we have, if I call it a traditional way of building a network, you have a big chassis from one supplier. In that chassis, you slot in blades that has a particular use case. It can be an amplifier, a WSS. It only works in that particular chassis. The chassis uses, or the solution uses, proprietary data models and proprietary interfaces, talking to a management solution that is developed by the same manufacturer as the box. That is a traditional way of running it. But absolutely still a valid option. The disaggregated building concept is that you break apart the functionality in individual boxes. In this case, I draw it as pizza boxes. It could, of course, be different ways of doing it. But it could be, if we look at just the optical level, one box doing the amplification, one box doing WSS. So you can actually build the best of breed solution from different suppliers, but also other layers as well, like firewall boxes. It can be router switches, of course. The difference here is that they use open and standardized APIs. So you can and common data modules, typically young-based modules. So you can integrate them into an open source network controller. This is kind of the view on what disaggregated open networking means. And what is it supposed to give you? If you do this correctly, and if you look at the hyperscale guy that was driving this, it's supposed to give you fast innovation. Basically, you can select the best of breed of the different components on the market and build a solution that is, say, tailored based on what is available on the market today. You do not have to wait for a specific slot-in blade from that particular vendor that you have been locked into. It is then supposed to give you cost savings. If you commoditize the hardware, you should have more competition and be able to drive down cost in your network. And if you have done this with open APIs and integrated solutions into it, the operational model are also supposed to be easier. And we will also see there that you can then, as I mentioned before, you can cherry pick the boxes and the solutions and software with the best-in-class functionality. And it then provides you with a flexibility so you don't get into this vendor lock-in situation. If you've done it correctly, I put that at last, it's supposed to provide simplicity. So you have a SDN controller, an integrated environment where you can then put a box from any supplier, and through open APIs, you're supposed to be able to, say, read, configure, and manage this. Is it that easy? Well, today it's starting to become, I would say, quite easy, or at least possible, to deploy completely disaggregated networking solutions. It has been a challenge for everyone that does not have a large R&D team. The big hyperscale guys, not a problem. They have, Microsoft through a large software development team writing their own controller and do all of this. They have the leverage to get exactly the right specification from the hardware suppliers to accomplish this. For an operator without a large R&D department, this is going to be much more difficult. So today there are independent third-party software solutions coming out of the market that provides this. But it is still a challenge to get the management piece together. You got to really think through your overall solution before you go this route. That is one of the challenge. Another challenge is, of course, that there are a number of different open initiatives on the market. What I've done here is I've summarized four of the different open initiatives, kind of randomly, or initiatives that we are associated with somehow at least. They are all, working together to some extent, but they are in some areas also competing with each other. So taking those then, I've summarized this with my own kind of words now, so it might not be exactly what if you look into the standard, what they state. But if we look at the Open ROADM, that initiative was originally founded or driven by AT&T. And now there is a large number of both vendors and operators that participate in this. They have specified down to the hardware specification level. They started with ROADMs. They've added transponders and muxponders on top of it. So they've actually specified both the hardware specification, but also the data models and the interfaces. They use Young-based data modules based on the Open ROADM spec, and they use NetConf as the management interface to discuss, talk to the network elements. Another initiative there that adds value into this optical segment is the Telecom Infra project, Telecom Infra project, TIP. So they consist of several work groups. The one that is most important for the optical industry is the Open Optical and Packet Transport Initiative. They specify a number of different boxes. They specify interfaces, and they do a lot of interoperability testing. One really interesting part of that initiative that we are, relating to is the multi-vendor simulation tool. They have developed something that they call GMPY, where they can simulate OSNR and GSNR, meaning non-linear simulations, over multi-vendor networking. And it does it very efficiently with very high level of accuracy. So that's very, very important if you're going to build a multi-vendor solution that you are able to plan, simulate your network. So that one comes in handy there. Open Config is another initiative that was initially focused on developing, independent young models. Today, there are a little bit more to it. They have specifically worked on the layer 2 and layer 3 side in the past, but we start to see now some layer 0, layer 1 initiatives around that. Streaming telemetry has been an important part that's kind of been used for quite some time in layer 2, layer 3. We start to see those requirements now coming down to the layer 0, layer 1 devices as well, using gRPC or something like that, but with OpenConfig as one of the standardizing organizations. Another, of course, important open forum is the Optical Interworking Forum, the OIF. They are specifying the electrical, the optical, and the, whatever you call it, the interoperability on the actual hardware, so more on module level. They are the one that are specifying the 400 ZR optics. They are also working on 800 gig and a 1.6 terabit pluggable optic specification that will then evolve over the next 5-6 years. So all of those you have to kind of relate to in order to be, an open networking provider. And you also, if you as an operator want to use disaggregated solutions built on this, you need to understand what kind of APIs the different boxes support, so you can build your solution together. So there are a lot of good things around this, but there are some challenges and things that you need to really pay attention to if you want to build a network this way. For example, when we built our new ROADM platform, we wanted to select an SDN controller based on those open initiatives. So we were looking to try to find, we did a pretty long evaluation of which route to go. We ended up selecting to go with the Open ROADM, even if we don't like part of that standard. So they have standardized exactly what the hardware look like. And basically, they have specified a Ferrari that's completely overkill for a metro network in the Nordics. So what we have done is that we've built a hardware that deviates from the standard, but we use their control plane. Why do we do that? Well, if we just take an example here on what they have done. So in the Open ROADM initiative, they have developed an open source SDN controller that they call Transport PC. It is developed actually from the operator side. So it's developers from primarily Orange and Telefonica that works on this to fulfill and create a controller based on that Open ROADM specification. So this is, of course, a very, very good starting point, because then you get an open source controller that can manage, our ROADM boxes, but also other ROADM boxes. So it provides a good framework for it. This portion of the network, it actually just does the optical part of it. It provides the path calculation, power setting, etc. But it does not do any of the, say, it doesn't have any graphical user interface. So you have to add some kind of orchestration layer on top of it in order to make it a useful product. But this is one of the, things that you have to relate to when you select to go with a disaggregated building concept if you want an end-to-end solution across multi-vendors. If we then look at what this is going to end up with, if we look at the end game here, if we take a pluggable 400 gig optics and run it over a disaggregated open line system, what kind of performance do you expect to get from it? So this picture here tried to illustrate that. I've taken on the top table there, I've taken some of the different modulations format from the 400 OpenZR Plus standard and added the OSNR limits. We've been running a simulation on a ROADM-based network where we run it over a number of spans. Each span then, or each ROADM consists of 2 amplifiers, preamplifier, booster amplifier. So that's how we generate noise. And then we simulate that based on some generic criteria for the amplifier. And then we come up with a table there that shows what kind of OSNR you will have after each hop. Looking at that table, you will see that you will only be able to do, on the OF 400ZR, you will only be able to jump 2 hops. So this is without any margins or anything like this, raw calculations. 2 hops of 80 kilometer to be above the 26 dB OSNR. If we look on the other hand on the 400 gig, when you run it with OFEC instead, you can actually, when you have 23.4 dB OSNR to relate to, then you can actually go 5 hops across a network like this. And in a small metro network that typically looks something like this, 5, 6, 7 ROADM networks, that actually means that you get any-to-any connectivity in a network like this with 400 gig pluggables directly out of your routers. So it provides pretty good optical performance, and it really becomes useful. Once again, you may have challenges with a low TX power in brownfield networks. In greenfield, you can build to compensate for it, but in brownfield, it is still a challenge. But with the optics, and that's why I said I think it's an important thing that the routers can go down in line rate. You can see once you go down to like 300 gig, you can go, 10 hop plus. So then all of a sudden you get really, really good performance even on those pluggable optics. Not to the same extent as what you do if you build it into more of a, say, long-haul transponder, but still very good from an optical performance point of view. So that was my last slide. Thank you.
Thank you, Ken, for a very good wide-ranging overview. Any questions? We only need 5 minutes for questions, then you can have your lunch. Don't make me keep you in here. No questions? Steve, have you got a question? Oh! You've lucky escape, Steve.
Hello, Uffe Andersen from Aurelion. My question is, how much do you think you're going to disaggregate the line system? Do you see a real future where you buy a VSS from one vendor, then an EDFA from another, and then an OCM for a third, or do you kind of see that still staying together if you want to operate in a practical manner?
Well, I don't think anyone will do that. I don't think that it will go that far. I think maybe on a node-to-node interoperability level, but I think it's probably going to be more of a one area or one metro from one supplier, another metro from another supplier with a common management solution for it. That's what I at least see today on how far people are willing to go in disaggregation. So that's what I think will happen, or that's at least what we see today. And I don't see anyone really pushing for a deeper level of disaggregation.
Anyone else?
Thank you.
Valeria here from Telia Denmark. I was wondering if you could comment a bit on the challenges with ZR Plus today, like output power, OSNR, anything that may require additional components beside the pluggable, if you want to go beyond those 5 ROADMs.
Yeah. There are a number of challenges. I mean, the TX power is, of course, an obvious one that really prohibit this to be used in existing networks. That will be, I say, dealt with already this year when the new type of optics comes out. The other part is, of course, the bandwidth. They are wider in bandwidth. You can run them in, like the question was before there, you can run them in a 75 gigahertz, networking. However, that's limited to point-to-point. Otherwise, you will start to get too much penalty. But if you have a 50 gigahertz DWM network in the ground already, you are basically screwed for 400 gig. It's not going to work efficiently. On the pluggable optic side, you will be able to set the 200 gig down to in 16 QAM modulation mode in the next generation optics that come out later this year. And in that case, you will actually be able to run them at, say, 50 gigahertz spacing in 200 gig rate, but not on 400 gig rate. Then you have the tunable optical filter part of it. Right now, the current ones, they do not have any tunable optical filter. It doesn't really make any difference because they don't have any micro alpha, so you don't have any white noise. But the specification doesn't stipulate that you should have one. They have a very, very poor performance on the out-of-band OSNR. However, the reality that we've seen is way, way better. So we've tested it up to 32 channels without having any problems on, say, recognizing and detecting the signal. But based on specification, it really, really limits the possibility of using it in any type of copper-based structure.
Last call for questions. Thank you very much, Kent.
Thank you.
And now the bit you've all been waiting for, lunch. Lunch is in the restaurants outside. If you could be back for 1:40, and then we can kick off with some lightning talks. Thanks all for coming, and see you soon.
Ladies and gentlemen, the conference will start in a few minutes. Please take your seats in the plenary. Ladies and gentlemen, the conference will start in a few minutes. Please take your seats in the plenary. Ladies and gentlemen, the conference will start in a few minutes. Please take your seats in the plenary. Ladies and gentlemen, the conference will begin shortly. Please take your seats in the plenary. Ladies and gentlemen, the conference will begin shortly. Please take your seats in the plenary. Ladies and gentlemen, the conference will begin shortly. Please take your seats in the plenary.
Ladies and gentlemen, this is your captain speaking. I would like to welcome you back from the lunch. I hope you had a good one. We are about to start on a couple of lightning talks. The first one up now is Tom, who's going to tell us about a couple of RFCs. So give him a warm welcome.
Yeah, good afternoon, everyone. I hope the lunch was okay. It's amazing to be back on stage after 2 years, or is it still April 2020, I guess, technically? So I'm going to talk a bit about two specific RFCs and how they relate to documentation and why documentation is always important. Let's see. It's not working.
You have to dance.
Where should I be pointing? In the back? There we go. So, like I said, documentation matters. And why does documentation matter? Well, here you see, like, we use Jira internally, and now you actually know what the network operations group we use as the internal ticket reference. So if you ever have like any open tickets with Cloudflare, you might actually see references like that appear. Now you know. But this specific ticket is one of our switches in EWR03, which is one of our New York deployments. Well, Newark, technically. I'm sure there are some people that are going to be offended by that. And specifically what we were seeing was weird things, because what you're seeing here is errors, egress errors on ports on a specific switch. And what you're seeing is this keeps flapping between egress interfaces. So the egress interfaces on these switches are connected to our compute nodes. So what you're seeing is, well, one interface starts erroring, so we drain that compute node with the expectation, well, you know, broken port, broken transceiver, broken whatever, and you just drain that node, you get an RMA ticket, you get it replaced, everything's fine. So we were expecting after that first drain for for the errors to just kind of go away and be done with it. But what we were seeing instead was this just moves to a different interface. like that's not what, right? So it's like, weird, shouldn't be happening. So what the hell's going on? So we were trying to figure out what was happening, and this specific platform was the Cisco Nexus platform. I think there's some people from Cisco in the room. And what we were seeing was, or what our understanding at the time was, is we're receiving a broken frame. So it comes in broken on the ingress interface, and because of cut-through, the frames are actually forwarded to the destination port. But what the box is going to do is it's clobbering the CRC on purpose to basically have it dropped on egress. So that's kind of what we were seeing. We were seeing egress CRC errors, but weirdly, we weren't seeing CRC errors on ingress. So still something's like very strange, not fully sure what the hell's really going on. Besides, like we clearly have something broken in our network, just having a really hard time to figure out what's going on. So what someone did, one of our SREs did, enabled RxFCS, which basically enables you to do packet captures on your interface, even when the packets are broken, right? So normally, if you have that turned off, it will just drop the frames and you can't even see them in the kernel. So TCP dump wouldn't see them. So enabling it allows us to basically get those broken frames to make that work. And yay, we have a TCP dump. Awesome. I've hidden a couple of things here. They're not immediately relevant. We'll get back to that. The weird thing was, so we're seeing basically at the end of our network, at the bottom of our network, right behind the spines, behind the leaves, at our compute side, we're seeing broken frames, right? So that's kind of established. But the weird thing is, like, where the hell are they coming from? Because like that needs to pass through at least 3 other layers of networking kit. Why aren't those layers seeing those problems, right? Because the expectation being, we're getting something broken from the outside, it's coming through the network, it's passing by our edges, it's passing by our spines, and it's passing through our leaves, and it's only the leaves at the end that see what the hell is going on. Fortunately, I have some friends, and one of them basically indicated that the Nexus 7 case specifically has a really long history of looking into packets that they probably shouldn't do. Specifically, if there's encapsulation happening, it might actually start looking at the CRC header of the encapsulated packet. And that really helped. Now, what does this have to do with documentation? Well, this should be familiar to most of you. Because a while back, a couple of years ago now, we did this thing called a DNS service on Quad 1. Might be familiar. But the thing with that is, there's certain vendors that have official documentation that is still online. And it uses, and I'll go into that here. Definitely not awkward. It's definitely not a conversation we've had with a couple of vendors in the meantime. Because, yeah. But to be fair, we're not, like, it's not just vendors, right? Like, everyone makes mistakes, and it's perfectly fine to make mistakes. To point that out, we're also doing the weird thing, just slightly awkward. So, everyone's at fault. Perfectly fine. But it's not always great, because the thing about making mistakes is you need to accept the fact that you've made a mistake, own up to it, and fix it. This isn't the right response. When you get pointed out, could you not, use these? That's not the correct response. I mean, people do what people do, but yeah. Because there's 2 specific RFCs, and they've been around for a while, specifically 3849 and 5737. 3849 is probably older than a couple of people in the industry at this point in time. 5737, it's getting there. Like, this can drink legally.
to reinforce, there's 2 specific RFCs. Please use the RFCs. They're there for a reason. The main reason, it stops me from getting weird 1.1.1 traffic that I shouldn't be getting in my network in the first place. Like, I don't need your ER span traffic. Like, I'm not interested in your like broken layer 2 switch that you're trying to debug and then not understanding why you're not getting the traffic in your receiver. Like, that's not my problem. Like, I don't need to deal with this. Use the prefixes. They're there for a reason. Like, for 3849, it's a /32 on IPv6. Do whatever you want with it. Like, that's a crazy amount of space, right? Like, that's just silly amount of space. And you can tear it up in 48s, 64s, all the things. Really good time. Works really well. 5737 has 3 prefixes. They're all /24, so it's like it's not as neat, but at least you still have routable boundaries. So you can still use that in documentation. You can still use that in like BCP documentation, where you're saying, it's like for IPv4, the routable boundary that's currently been established is /24. You can still indicate that way. You can use that for your ER span documentation. You can use that for your Argo tunnel documentation. You can use that for your labs. All the things. Because I'd like not to have to reuse this meme on an almost daily basis whenever I'm seeing like vendor docs, because unfortunately that's kind of the position we're in today. Is either it's because I notice weird traffic coming into like a location that I shouldn't be getting, and then trying to, we wasted like 2 weeks on that ticket because the fuck, like I shouldn't. Weird like switching behavior, that's fine, but that wasn't documented either. Like, the only way we figured that out is industry contacts, and we shouldn't need to rely as operators on industry contacts. So that's one problem. Second problem being, an operator is either labbing something or testing something or trying to understand something, and the easiest way to do that is I'll just copy paste the vendor docs, because why not, right? Like, that's the default configuration, that's the recommended configuration by the vendor, and then I'll figure out what I need to change. But that means for, I think that was like 3 days. 3 days on end, I get ER span traffic with broken frames in. Like, I mean, it's fun for me because I get to do talks about it. So, but save yourself the effort. Save yourself from me yelling and posting memes on Twitter. But that's basically it. Like, there's 2 specific RFCs. Use the RFCs. They're amazing. They're available. They work. Like, Alan has nicely indicated in his own slides, like, he used the documentation prefixes. It's great. It saved me from yelling. I like that. That's always a good thing. So thank you, everyone. Hopefully I've made a difference. Maybe. Like, if you notice internally documentation using 1.1.1, point them to this slide. Be good people, be nice, that'd be appreciated. But yeah, like, you can always follow me on Twitter, so you can find the vendors that don't listen. Or you can always just send me an email if you have like any examples of bad config from anyone, and then I get to yell a bit more. But thanks, everyone.
So since it's an RFC, is there any comments or questions?
Henrik Kramselund from Security. Just a small fun comment about the Danish police at one point put out a PowerPoint presentation where they were using like the 10, 8, that's private address space, and I think it was 11 and 12, which were actual networks, and one of them were the hacker in the presentation.
The 10 and 11 space is 11 and 12 is DoD space, I think, as well. So sure, the Americans appreciate that.
Anybody else?
Hi, Mikkel from Subspace. In a previous life, we had the opposite problem with a big Japanese storage provider where all the field engineers were putting all the management network into the documentation range, and when you ask them, like, well, the documentation says it should be this, so.
The benefit with that is that if that inadvertently leaks, if the networks use BCP38, it should be filtered as a bogon, so it doesn't propagate.
No.
Unfortunately, we've had multiple incidents ranging from Verizon accepting a /29 from one of their customers because they turn up 1.1.1.0/29 on a peer-to-peer link because reasons, and then Verizon accepts that, and then suddenly everything breaks, and you're wondering, why is DNS traffic for the US hitting Rio de Janeiro? Things break, but there's benefits because I don't run a service on the documentation ranges yet. We'll see if Jeff decides to hand that one to us at one point or another.
All right. Anybody else? No? Well, thank you again, Tom.
Thank you very much. Awesome. Thank you.
And the next lightning talk on the program is Steve Jones. There you go.
Sorry.
You need to get your microphone on first. So.
Good.
Yeah.
Dance. Yeah.
No, I won't do the dance. So please, warm welcome to Steve. We got a thingy. Good afternoon, everyone. Bit technical, which one to press? The big green one. Afternoon, everyone. My name's Steve Jones from Huber and Sooner. Just for those who don't know, Huber and Sooner are a Swiss-based, Swiss-German organization, and we do everything from fiber patch cables, patch cords, WDM systems, transceivers, all the way through to all optical cross-connects. So a wide portfolio, but we don't do these things. The green button, yeah? Ah. So going back to optics, because I know much of the room has, you missed out on your optics conferences. So just going back on some things on 400 gig and DWDM. So you've seen similar presentations already once or twice today about 400 gig transceivers, and the answer is there's lots of them. I was at a DKNOG talk just before Easter where Lynx presented that they're now offering 400 gig on the client side. Obviously, there's quite a few organizations offering 400 gig in the core, but they're offering 400 gig on the client side. And they're using a mix of 400 gig LR4 or FR4. That's what they're offering, and the reason they're offering them is because that's what their Nokia kit supports. So there's lots of different 400 gigs out there. Fundamentally, it'll be driven by what your vendor supports. This is a presentation. I'm in a sales marketing role. I've got to have slides like this because it shows futures. As already been discussed and mentioned this morning, the ZR optical over IP WDM is definitely happening. 400 ZR volumes are going to increase. These all come from Del Oro and other research organizations, Signal. So these are all the marketing companies telling us this is all going to happen. And it is happening. It is happening. And 800 gigs come in and things beyond there.
The first talk this morning was about greenfield versus brownfield. How many totally new networks are out there? Virtually everybody has a network where they have to maintain for some period of time existing services. So the wonderful blue sky world of 400 gig is going to happen, is happening. But it provides more complexity. You've seen lots of different sides already showing the various options for 400 gig. One thing that perhaps hasn't been mentioned, but any of you having power as an issue, increased power, therefore heat, is an option. And as I mentioned, network integration, you have to keep the existing services working. If you pull a customer off, they won't be happy, right? They'll let you know about it. So I'm just going to now move on to this wonderful world that is ZR and OpenZR and even some proprietary stuff. And I haven't got every single version here, okay? There's lots of websites and great presentations. We'll give you a lot more information on this. Vendor interop was mentioned this morning by Kent, right? In theory, yeah, not a problem. In theory. So they can do various things. Optical reaches are different things. We are seeing, just as a point of going for the Infinera presentation, there is a move towards more online 400 gig coherent solutions, without a doubt. Modulation changes, and I'll touch on modulation again in a moment. So modulation changes, and there's different versions available. Launch power, client interface power. Did I mention power? 20 watts. 26 watts on some of this stuff. I hope you've got your data centers set up, ready for all of this. And then you have different form factors. You have QSFP, DD, OSPF, and CFP-based solutions. What we're seeing is, and maybe Flex Optics and others will see the same, we're seeing a move towards QSFP, DD as the default, as most people are going that route, with the exception of some onboard CFP-based stuff. But it's complicated. As an industry, we love the fact that we're moving ahead at a huge rate. We invent stuff really, really well. We've got some really clever people in this industry, but we have to maintain what we've currently got. So just going back again, I'm just re-emphasizing the point that Kent made. So this is a standard ITU grid, ITU G694.1, if you want to go and have a look. It's specified DWDM. All DWDM vendors use this, so you can have DWDM vendor A at one end, DWDM vendor B at the other end. We can always talk about losses and amplification and stuff a separate time. A typical DWDM system uses 40 channels with 100 gigahertz 0.8 nanometer spacing. It was a question mentioned this morning. You can have 50 gigahertz spaced muxes as well. They're typically used in 80 channel muxes. The point of this one is we're actually looking at the midpoint here. So it's 100 gigahertz between the midpoint. We just chose 3 channels at random. Channel 21, 22, 23 is 100 gigahertz spaced. So it's a 100 gigahertz spaced solution. I'm going to have to get my gigahertz and gigabits correct in a moment. So whilst it's 100 gigahertz space, the passband is typically around 50 gigahertz. Most transceivers, 10 gig, 1 gig, 100 gig will work in a 100 gig DWDM will work in that 50 gigahertz band. So because they're also used, as alluded to earlier, on the 50 gigahertz spaced standards as well. So that's where they are. That's the laser width. With some coherent optics, the width is slightly wider than the standard 50 gigahertz passband. So that means that, I'll just take a step back. So 400 gig is becoming more widely used. The easiest way to deploy WDM is using passive WDM, 100 gigahertz space passive WDM. Easiest way to deploy it, and it moves towards the IP over DWDM. whilst we talked about 40 channel and 80 channel muxes, if we're looking at the metro access, often they're 4, 8 channel muxes, but they still conform to the 100 gigahertz space standards, but they're typically 4 or 8 channel muxes. You don't need a 40 channel mux in your access network. So with 400 coherent transceivers, as I said, they're slightly wider than the standard 50 gigahertz passband. Some, I must say some, not all, of course. Now, which ones? We're still working all of that. So for some 400 gigahertz coherent optics, you might need a 75 gigahertz passband within your 100 gigahertz DWDM grid. We okay with that gigahertz and bit? Okay. 75 gigahertz passband is certainly wide enough for all 400 gig coherent transceivers. Plus, of course, it'll work with any existing optical services you've got running over that DWDM network, because you have to keep that 10 gigs or n times 10 gig network running. You can't just switch it off, or 25 gig, or 100 gig, or whatever it's going to be. One example, INEX, Ireland, most people here might know of INEX. They wanted to run 600 gig using 64 QAM. There was 2 locations. One was about 7 kilometers, one was about 14 kilometers between their data centers. The link came up and it was running and it was working, but what they noticed was they're having high bit error rates. We worked out they needed around a 75 gigahertz for the 600 gig modulation to work, because they still had, I'm repeating myself, I realize that, it's my age. They still had to keep going with that those 1 gig and 10 gig services whilst they were rolling out this 600 gig service. So what's the solution? There's 2 options. Option 1 is use a 200 gigahertz space mux, because then they just miss out every other channel. And that's what INEX chose to do, because they're running 600 gig and they thought that was, maybe a couple of 600 gigs would more than meet their needs for a couple of years between these data centers, whilst they kept running the existing services. Option 2 is use muxes that are capable of 75 gigahertz passband with it, because if you have muxes in the 100 gigahertz spaced spectrum with a 75 gigahertz passband, you can run all of your 400 gig optics of your choice or your vendor's choice in the future over a DWDM network. My talk was very short because it's a lightning talk, and it's just after lunch, I know. Any questions?
Before we head into questions, I just want to remind the next speaker to go and get his microphone on. Perfect.
Hello, Matthias from Cisco. Thank you for a very interesting and fascinating talk. I myself don't work a lot with optics in my day-to-day life, so I don't know the history of this field that well. I'd be quite interested in how did we end up in this situation where the passband for coherent laser optics is slightly wider than 50? Is it down to standards being defined by people who weren't talking to the right people? Are we dealing with physical limitations that necessitate you simply cannot go to 50? Is it something that's here to stay now the standards is written, or are we hoping for a bright future where we can actually get into the 50 hertz passband? Sorry, that's actually a lot of questions.
It's just a lot of questions.
But it's a very interesting talk, I'm sorry.
The answer is, it depends. It's like if you build any new network, you wouldn't build what you've currently got now. You'd start from somewhere else. So a lot of this is historical. A lot of people have developed stuff. And a lot of the limitations are to do with the modulation that's used within the 400 gig So it's a modulation issue rather than an amplitude issue or anything like that. So we are where we are. We sometimes, as an industry, charge ahead and then go, maybe we should have thought about that. And this isn't just optics, guys. This is across the industry, right? So I don't have an answer for you. But I'm sure some very clever people do. That's not me, though.
If you suddenly find yourself clever, I'm sure you can find Matthias at the social tonight.
One more down there. Needs to get these steps in.
Yeah, hi, Eric from Glasses. How likely is this to repeat itself with future standards? And will 800 or 1600 megabits per second also creep a little bit wider, so you have to keep replacing your muxes every 5 years or so?
Well, please keep replacing your muxes every 5 years, because I've got a wife and kids to support, okay? Every 3 years, if you must. I think it depends on modulation. It's a lot of it's down to modulation that's used. I don't know the answer to that, I'm afraid. We are pushing the envelope on some of this stuff. There's some really, really clever stuff going on. And it's not, please don't take away saying that what's been done so far is wrong. It's not. It's just where we are. And there are solutions that are easily deployable to overcome this little bump in the road. We're just making you aware that there's a bump in the road. It's not wrong, it's where we are. Anyone else?
No. In that case,
thank you, everyone.
Thank you very much, Steve.
Oh, thank you, young man.
Let's see. So the next talk, now we are out of the lightning talk and back to an actual long talk.
No.
And here it's my pleasure to
welcome
Martin, who's stepping in for Ron, who's supposed to be here. And we are very happy to have him talk about TCP and TCP authentication option.
Yeah, the TCP authentication option. Yes, my name is Martin Janus, and you probably don't know me very well, but I have been in the BDP development area for 20 plus years, the last 12 at Juniper. So I feel very familiar with how BDP works, how BDP is deployed, the issues you might see. This talk is not technically about BDP, however, it is something very important to BDP, which Ron came up with over about almost 10 years ago. It's called a TCP authentication option. My goal here is that you come home and saying, I want to use this. But before we start this talk, I kind of would like, anybody here who's using BDP authentication in their network today? The authentication option, TCP authentication option. One. That was more than I thought, thank you. Anybody who uses TCP MD5 on any sessions? There are some. Okay, that's a lot more than I thought. That is also very encouraging, so that's very nice to hear. That's good to know. Let's see if I can move. People have had problems with this. Okay, so first of all, why do we need TCP security? That seemed to be such an obvious question, but I'm still going to say something about this. I don't know how many of you who was aware of it, but back in roughly 2004, there was a reset attack on TCP. TCP sessions are long-lived at the time. Most BDP configurations are pre-configured, so IP addresses, source and destination IP, the BDP protocol number, they are all static. Right? They're easy to guess from an attacker. So we have the TCP source port, which, okay, not that hard to get to it. After all, it's a long-lived session, so on. There's ways to get to it. And what people then did, or what attackers then did, was they started sending a slow rate of TCP resets to a spoofed network. They spoofed basically some peer's address and tried to send it slowly to the setup. And because they were using a very low rate of just TCP packages with a reset bit set, it went under the radar. And eventually, by doing random sequence numbers, the reset message would hit the TCP window that was currently valid, and poof, the session would go down. Now, TCP session going down, if it happened to be, telnet, whatever, you might not think it's bad, but because BDP's protocol is reliant on this session staying up, it means that when the session goes down, we tended to take down all the routes and withdraw all the routes from the peers. Basically, there's a big churn in the network. So it would be quite catastrophic for most providers if that happened. And even though the session would come up again and after this, it was certainly a scary moment for them for that setup. We have BTSH or DTSH as it's called nowadays, for the generalized TTL security hack. That one can prevent you from getting packages in that is coming too far away. But we see local networks get hacked. With SolarWind, for example, they have hackers have access to their local network, meaning that you cannot guarantee that nobody have hacked into your network to sit and send these messages through your network. So basically, anybody who is in your own network might be able to spoof these messages. Also, they don't really apply to IBDP in the first place because the way IBDP is designed to not do the TTL check. And while you can do a multi-peer, or you can do filtering on your peering sessions, if you have 1,000 peers, you have to remember you have to at least make sure that none of the 999 other peers could possibly have been sending messages as well, more than on their interfaces. Otherwise, every single one of them would be a potential attack. There's a lot of ACLs, a lot of things you need to get right to make sure things is safe. In 2004, people started then really quickly trying to deploy MD5 in their networks because it happened to be the way we quickly could get some level of security. Even back then, MD5 was known to be on the edge of going out, basically being insecure. The MD5 algorithm has been hacked in the meanwhile. It is considered not a secure hashing algorithm by today's standard. So we really need something better than that. The other thing people realized quickly was, Jesus, how do I change the password? MD5 doesn't have inherited key rollover. So changing password could work if you set console to console and pressed enter on both sides. If you were within a couple of seconds, it probably worked. If it took longer than that, it might not. And I said probably, there was no guarantee, right? It was just happened to be possibly working or not. So that certainly was a problem. And because of this, years and years later, providers were seeing that we're using the same MD5 passwords. They had people leaving the company. Technically, they know the password, and had nobody have ever changed the password because of it, or at least very rarely because, Jesus, I don't want my TCP session to go down. That's why I did this in the first place. So that was kind of the, how do we encourage this? There's also replay attacks, which is an issue. And I'll get a little more into it later, how here the TCP authentication options deal with that. But basically, that is also one of the things it helps with. I have mostly spoken about this. So I will skip over the slide as I mentioned it before when I talked. So MD5, the way the option work is it takes TCP payload, including what is called a pseudo header, so IP address and port numbers, and it calculates the hash and inserts it into the message and sends it out for every message. That and the receiver will it gets the message, and first of all, if it doesn't have a hash on it, it will, of course, will discard the segment. But at the same time, it will, if it works, it will then recompute the same thing, and it will validate if the MAC is right, and if it is, it will move on. It will accept it, otherwise it will drop it. Works, as I said, but the problem here is you can't, MD5 is old, not trustworthy, and we can't change the password. So the new requirements is we need to be able to do key rollovers, we need to also, another thing we strongly believe in is that we need to be able to implement this new option, TCP authentication option, in a way that we can add any algorithm later without changing the protocol. Now, it doesn't mean that code doesn't need to be changed, because if somebody adds a new smart algorithm, you have to, of course, implement that algorithm, right? But there is no key points that need to be allocated at the IETF. There's no data in the IETF that need to be pre-formatted in a certain way in the TCP option to make this work. There is just the authentication option, and it has the ability to do so. I just need to check that, how it on. Okay. Yeah, that's basically the ideality. We need stronger the ability to move on to stronger passwords as we are having now. So now, how is this implemented in TCP authentication option? So the TCP authentication option has what's called an MKT, or master key tuple. Basically, you have a master key, and it, in addition to the regular passport you will recognize, has some information like what kind of hashing algorithm is it using, what kind of parameter session does it apply to. Most say, I know there are multiple vendors that have implemented it this way. For example, is this valid until a certain time or in a certain time window? So you can set, for example, a validity of your password to be until midnight, tomorrow night, and then it will switch after that. It will be seen as invalid after that. What it also does, what TCP authentication also do is, it uses traffic keys as opposed to the real keys. The master key is not used on a hash like it is in MD5. It's abstracted away. So it uses the primary, for almost all messages, it uses the initial sequence number to generate together with the known topology numbers, so IP, source, destination, port numbers, and so on. It will, and that sequence number, it will generate a send and a transmit key. And these keys, the send and transmit keys, are used for the actual sending of data. It also means that if somebody knows the master password, they can't recreate the actual key that's used for the session unless they know what the initial sequence number was at the time. That means that just because that you're using the same password for 2 sessions, that the 2 sessions are not using the same security key for passing on for ensuring your data is untampered with. Right? So that makes it way better in that also the actual key you're using, TCP session goes down and come up again. It's a new session. It's a new key that is generated for the new session always. It also uses a hold on, give me a second. So it has the following data in the actual TCP data it is sending. It's sending obviously the MAC, but it sent the key ID and it received next key ID. The key IDs is a configuration thing. You can specify any value you want, 0 to 255. There are no reserved numbers. There are no invalid numbers. You say that in, for example, Juniper or Nokia's implementation, I know they say configure ID 25 is whatever algorithm I want to use. Here are the session it belongs to, and this is being applied as transmit key for this session, and I can use a different one as a receive key if I want to. Which means that whenever you're doing that, the receiver side just looks up and saying, okay, I have my receive key from this session, and now I can check what kind of hash algorithm I'm supposed to use for it. And since the receive key is a part of the check itself, it can't be tampered with. I know it's safe to use it, and I can take it as an indication of which algorithm I'm supposed to, which master key and which active key that is used for receiving data from that session. So that means that we have the flexibility and agility to move on to these other, all of these other keys later on. There are currently at least a couple of different implementations of key algorithms already that works really well. It also has another one. It's called a receive next key ID. The receive next is essentially the sender says it is used for rollover, first of all. So basically, the receiver says, I am now sending you a packet, and I'm expecting you to send the next key to be this value. And if the sender also has a configuration that says, I'm supposed to be sending this key soon, or actually I have a valid, because you can have multiple valid sending keys. If I have a valid sending key for this, then I will move over to it and use it following for the next packet coming back, but not before. And that means that the rollover is coordinated between them, and they will both switch at the same time through the receive next ID. Okay, so the master key tuple has connection identifiers, as I said. You specify, for example, with or without wildcards, by the way. This is the IP addresses I will allow this key to be used for, so that when I put it on the system, it applies to them, even though it was misconfigured, maybe on a different session or whatever. In that case, you won't be using it. You can also do things like if the options section of TCP is included or not. That is the information. And then there are the sending and receiving key identifiers, which I talked about right before. They are used exclusively to hand over between the two sides. There is nothing in the protocol to specify what the values are supposed to be. They are coordinated completely by the two sides when they configure the routers, and are only used to identify which MKT to use for validation. There are technically 4 different keys generated for each MKT. There is a send sync and send and receive sync, and then there's send and receive other, the generic ones. The send and receive sync is going to be used when you set up the session. Send is obviously sending the first sync over for the TCP connection. There's still no ITIN. You have no initial sequence number, so you can't just say, this is the sequence number, so I can't use it. It is basically set to 0 when a new key is generated. But for everything following, they will move on to the one with the send other key. Send or receive other, I should say. The receive send is only, or these two usually are only used either one of them. It is only if we have something called very arcane old TCP, which I don't actually think that anybody is really aware of that is supported. Simultaneous TCP open, where you get a send from the same TCP session at the same time. Then you can have both of these two active, but otherwise you won't see both of them. This is how the authentication option looks like, and if you have seen the RFC for MD5, it's very similar. There's a difference here, is the length value is now part of it, and obviously the key IDs are in here. Now, the length is included. First of all, both of the setups we use today are using the same key length, simply because it's considered okay from a security standpoint to use that length today, but the length is completely flexible in the spec. Any future defines on how you want to use it, can use any length you want. And key ID, as I said before. So basically, okay, we put it all together. So each node is configured with one or more MKTs, and whenever they have an MKT, they derive traffic keys from the MKT. So that means there's an abstraction that whatever master password you have in your MKT is not used for actual traffic access. The traffic keys are then used for hashing or validating your data, and validating the data. And then one more thing is that basically today, you could technically use any method you want to synchronize when you're going to switch over to another MKT. There is nothing in the spec that says anything. As I said, I know that Juniper and Nokia are using time. So basically at a certain date and point in time, I can't remember if Cisco does it too, but definitely Cisco has also an implementation for AO. But basically you can do that, or you can do any other method you want to. You can have an out of band or phone call, whatever you want. I mean, I don't advocate a phone call, but I'm just saying you could use any other protocol to do that if you felt like. Again, the procedure for TCP/AO is very similar to MD5. It calculated the MAC, the message authentication code, based on the segment and the TCP properties, and it inserts it into the segment. And then from the segment on, it is sent out on the other side, and on the other side it receives. It identifies which key is used, and based on which key is used, it will then validate the packet. Okay, so here are known releases for support, which support this. Linux, this is a slightly old version of the slides, it doesn't matter. RIPE is funding the Linux implementation and is being committed as we speak. And Wireshark, also the same, is being committed as we speak. I mean, that's not RIPE, was I think some university students who wanted to do that. And there is GitHub repositories where you can find some configuration examples and so on for these, and I would definitely suggest you go and have a look. As well as I think you should listen to Ron and a great presentation on the Routing Table podcast. Since it wasn't me, I can definitely do that. Now, why don't we just use DTSM instead? I kind of started out by saying most of this in the beginning, so I just will do this one very quickly. Because I don't think there's anything I haven't said why it's not just enough. We have to use security in layers. We can't just assume that I have implemented, let's say, ACLs around on my network. ACLs can go wrong. You have an IP wrong. You have applied something wrong. You forgot something. You thought it was working, but it isn't. That's actually the worst thing, because suddenly somebody can come in behind your back and stab you on your back, and you didn't know. So we need more layers, and therefore really, what I'm going to come out of this is I want to encourage you guys to deploy all of them, because we really need them. And I really think you should switch on TCP authentication option as opposed to MD5 for sure, for all the ones that already does it. There should be no drawbacks, short of that it's still kind of not everywhere. All platforms, all versions of code, of course, doesn't have this. I'm aware of that. I know there are many providers that runs around and run, not just 2-year-old code, but even older than that. Apologize, but I'm certainly aware of that. So I'm not. If just a couple of you come home and take it up, I think that's a win. I don't want to go over this slide specifically, but basically we had done interrupt testing together with Nokia. It was done during the pandemic over the internet, and nobody had to meet in person. Virtual machines and all of that works really well. And these are the two algorithms here is the ones that have been used. The configurations you can find online as well in the repository. I do want to mention here there was firewalls. We found that there's firewalls that actually modify the MSS in the TCP, and of course, it caused TCP/AO found this and saw it to be invalid and dropped the sessions. It took a little bit of debugging to realize. So keep in mind that can be. Questions?
Are there any questions?
Hello, Matthias from Cisco.
Welcome.
If no one else will ask a question, I will. For this, you talk about there's a lot of flexibility in terms of which authentication algorithm you can use, and multiple ones exist. Can you just elaborate which ones already are implemented and work well, or just, I presume, is it on the GitHub, or where can I find that?
No, that is, so I don't remember the FC number. This 1+1 has actually listed the ones that are currently recommended to be, implemented. SHA 196 and EAS 128 CMAC has been implemented and verified among Juniper and Cisco, and both of them. So both of these two are tested. I have absolutely, I don't have the overview over which ones have been implemented and tested as well. But the spec is open for anything can be done. That's kind of the point. Yes. But good question. Yes? Oh, sorry.
Hey, I'm Emil from KNET, and I'm also a student at TTU. And actually, one of the things that I'm looking into is protocol security and validating the protocols in a general sense. And that's why I wanted to ask if you are doing any kind of protocol verification in a formal sense for this, or if it's more practical testing.
So this specific option here has nothing to do with protocol, security, but it ensures that a MAC is calculated and ensure that nothing has been tampered with, including the TCP option header, TCP header. And the problem with, for example, TLS and SSH and so on is that they all look at the payload. So you can reset any TLS session by injecting something that looks to be valid with a reset bit set on it, and the session will just randomly drop. This is not about you can't tamper with the data since it's basically checked on validated. But it's not about did the person send what you really thought it would, and we have other protocol works that is both deployed as well as in the works on how do we ensure that, for example, the AS, which is in the BTP the route that's in the BTP protocol, was actually advertised by the person who was supposed to, and so on. The work that's there has been ongoing for 15, 20 years, I think, for real. And it's a cost benefit right now in that it's super expensive to do it right. Everything needs to be signed. It's really cheap to do it as done today, and nobody is really willing to pay the full price, and therefore the lever right now goes here. So there are some prefix validation which is done internally in BTP, where you basically get a data feed from a server, a route server that tells you this is the ones that are valid, and then you will either drop them if you think that yours is not enough. But if you have further questions like this, I would love to talk about it, maybe tonight or afterwards.
Okay. Any other questions?
Henrik Kramselund from Security. Is it handled by the control plane, and what happens if you get like 1 million of these packets per second?
It is control plane handled. Yes, we're aware of that. If you get 1 million packets, usually your host path DOS protection should kick in. One thing is that we kind of can take most part, vendors, maybe not 1 million, but very close to. In fact, BDP tend to be like 99% of the control traffic in the first place, right? So we today sometimes from some platforms had the problem with that we would outrun the DOS protection which had been put in place from the platforms because they assumed that we would never reach that amount of data. But if we have tens or hundreds of internet feed, or let's say tens of internet feeds, and then suddenly the system is restarting. You do a clear all and all of that. The amount of TCP/BTP data that comes in and out there is very big. Lots of messages, but not 1 million. Usually DDoS should take care of it. I'm sorry, I have one question though. Did anybody think that they were going to go home and take a look at this? We didn't do that before? Okay, sorry. I had hope. Oh, there was one. Okay, you saved my day. Thank you so much. Appreciate it.
All right. Thank you very much, Martin.
Thank you.
All right. Before we start with the next talk, I just want to give a quick service message. If you go to DKNOG12.dknog.dk, our conference website, there's now a new menu option called Surveys. If you click on that, there's a survey point for each talk. It's just one question and a free text box that you don't have to fill out. So please go in. The feedback will be valuable to us all, including the speakers. And now it's time to listen to Nina, who will talk about BGP monitoring. So give her a warm applause.
Thank you very much. Hello. Very, very pleased to be here. I realize I think it's the first time I speak at a DKNOG, which is kind of interesting after 12. Not good. Anyways, we're trying to make up for it right now. And today, we're moving a little bit up in the stack. I realized that it was almost a BGP topic we had before. And I realized that my title, BGP monitoring, could actually apply to the sessions. Are we monitoring the sessions? Are they up and down? And I think most of us, well, I know that some people have given up on that because they have so many, but usually it's in everybody's interest, they're up and down. But that is not the topic of what we will talk about. But first, I want to give just a slight introduction to the company that I work for now, Kentic. We operate in the space of what we call network observability, which is basically the ability to answer any question about your network. And those questions are all about, if we look at it very broadly, it's about how is the traffic flowing? Is it the network's fault when something breaks? Is it the application's fault when something breaks? Do we need more capacity? Are we under attack? And where are my routes being routed? So Kentic is an American company. We have around over 300 customers. Every kind of network. It goes from carriers to enterprises to digital services to financial institutions to whatever. We put some of the more known logos up there. And most of our customers are very happy about us, and we're definitely very happy about them. But what we're talking about, what I'm going to try and talk about today is BGP monitoring. And that's just another question from our point of view that you should know about in your network when you're running a network. So I'm kind of curious, how many here consider themselves a network operator? I know we're at a NOG, so it should be many, but I just want to take a... How many are software developers? How many are both? Yeah, that's what I thought, right? So, but I think this, and how many are thinking about routing security and BGP in their day-to-day life? Not that many, but you know, I'm talking to you guys. Or maybe you know this already, and then we can enlighten the rest of them together. So what kind of inspired me to start talking about this was I was listening to my colleague, Doug Mandori, and Joop Snijders from Fastly's talks at NANOG a couple of months ago. Is it already? Yeah, something like that. And they were talking about that, you know, we're reaching critical mass when it comes to our KPI. And just a reminder, our KPI is the ability, the way we're securing that the prefixes that we are receiving and sending using BGP on the internet are actually originated where we want them to be, the owners. They have secured that nobody can hijack, or it's a little bit more difficult at least to hijack their prefixes, more specifics. You know, if everybody adhered to this, do we reject the invalids and everybody is signing? We have a lot of security on the internet. Why should we care anymore? And they were looking at, are we getting there? Because it's taken a while for this to be implemented. There's a lot of objection to it, like we have some centralized stuff on the internet that's decentralized. We don't really like that. But anyways, if we look at the traffic that's being routed, we're actually reaching critical mass. It is only very, very small fraction of the internet traffic that's being sent, the volume of the traffic, not thinking about the counting the prefixes, but the traffic being sent that is going to prefixes that are invalids. So it should be safe now for everybody to implement dropping the invalids. So happy new world, routing is safe. So do we even care about thinking about should we look at the global routing table and see what's happening with the prefixes? And obviously, you all know the answer to this, but I'm going to state the obvious. Yes, we should still be looking at what's happening with the prefixes on the routing table. I just want to repeat the really good best practices that my two colleagues gave in that talk, which is all of you, think about, create your ROAS, reject invalids, but do not look at the invalid status and do some routing changes based on that. That can create bad things. Don't do that. Don't change your local pref. You might start sending traffic to your customers that you don't really want to send to. And don't, change the communities and all that kind of thing based on invalid status. Just a little reminder, and then go home and think more about AirKPI if you want to. Or you should, not if you want to. You really should. But I'd like to talk about all the other things that we can monitor. And now our KPI is actually just yet another thing that we should keep an eye on when we're looking at the prefixes that we receive from our peers and our transits, and us looking at how is our prefixes routed on the internet. So it takes two sides, and I think I probably just mixed it all up, so we'll just talk about each of the use cases as we go along. But we think about DGP monitoring in two ways. How is my address space seen on the internet? And what do I see coming into my network from my connections to the internet? And I've listed this is the list of monitoring things. I probably forgot something, so please let me know afterwards or during the questions what I've forgotten, and we can have a conversation about that as well. But first of all, let's talk about monitoring, withdrawals, and announcements. Why would we care? Well, I know somebody who cared in January or February when some prefixes disappeared on the internet. That's a good case. If your prefix disappears completely, or a prefix where a service that's important for your customers disappear on the internet, you want to know about it. Anybody know which event I'm talking about? You can yell it. Yeah. Anyways, but there is another case that where we should consider this as well, because are we seeing a lot of withdrawals and announcements of maybe our own prefix? Or again, a service we care about is served from that prefix. What does that even mean? Well, that means that somewhere on the internet, somebody might having a session that's flapping up and down. That will create disturbance of traffic going that way. And maybe it's something you can do something about. In particular, maybe it's inside your own network. So you could investigate that. And if it's somewhere on the internet, you could do something to route your traffic away from that path. So it's good to know, and it's definitely, if it's disturbing your own service, it's something you want to know about when you're running your network. The next thing is reachability. I mean, we put our address space out on the internet because we want the internet to reach our addresses. That's as simple as that. And most of the time it works. And should we think about whether we're reachable or not? Maybe not. But I remember one case from when I was sitting as a network engineer and announcing new prefix space. It was really, really interesting to see how long did it actually take for this space to be accepted by everybody on the internet. Was it a couple of days? Did I actually have to call somebody and ask them to update their filters? I actually did sometimes. So I know that we don't really have that much new space, so maybe it's not that often. But I also know that people are trading space with each other, and all of us networks that grow, we will have new address space. And it's interesting, we really need to know in an easy way, is it reaching everywhere on the network? Is it safe for me to start putting my services on that space? The last thing on this slide is leaks. Leaks are fun, right? And we can always do something about it because I am not making mistakes in my policies. So the most important place to look for leaks is inside my network and when I bring up a session with a new peer or with a new transit. But the thing is, leaks are really, really difficult to protect yourself from. So you want to know if your addresses are somehow involved in a leak space. And why can that have that big, really big consequences? That somebody in, say, India is leaking all of their address space to their provider? Do we really care about that? Well, we do because we have the local press thing. When we do, is everybody here familiar with BGP? That's what I thought. All right. Awesome. So, are you also familiar with the best practices going, we prefer sending traffic to customers, or we're sending it to peers, or we're sending it to our upstreams? Most of us. Well, most ISPs prefer that. Why is that? Well, customers pay you. Peers are free most of the time. And you have to pay you upstream. So I want to send the traffic where it costs me nothing, or where I get money for it. Yay, money, we like that. But what happens then if you have one customer that's dual-homed and they have a fat-fingered engineer? The engineer opens up the policy and announces all their space they have in the routing table to the other upstream. Well, then your network, that might be even far away from this customer, will certainly have, from maybe a big provider, best route going down to that customer because of local pref. Woohoo! Not very good. My colleague told me a story about that happening to Comcast and an Indian provider a couple of months ago. And for half an hour or so, all of Comcast address space was routed to this little ISP in India from some of the big providers. Not a great situation. So leaks are important. We want to know about them right away, at least so we can call somebody and yell at them. So another thing to think about, and this is one of the things that our KPI is helping us with, is origin changes. I have a prefix. I know it's supposed to come from this ASN, or it was originated in this ASN, and suddenly it's originated somewhere else. Uh-oh, do I really want that to happen or not? So sometimes it's okay, but you want to know about it. And sorry, I have to stand the right place. And also, if your customers or you yourself is using a critical service that comes from a specific prefix that has a specific origin, if suddenly that origin changes, you might want to stop sending that traffic. Maybe it's a bank, maybe it's something that has confidential information, whatever. You don't want that to go somewhere that you don't know about and that you don't think is right. So again, an important one, we all know hijacks. We all remember back, I don't know. No, actually, I see a lot of young folks here. You do not remember when we all routed YouTube to Pakistan, because some of you were not born then. But some of us remember when that happened. And as I mentioned before, our KPI status is an important thing to monitor. And one thing that is also important to think about when you have our KPI status, because you might want to drop the invalid, or maybe not. Maybe it is actually important that maybe they broke something and you still want to send traffic to them. Maybe they were just sending more specifics, and they forgot to sign a ROA for the more specifics. So I think a good thing to look at as well, we think it can take is that not only is the status of the ROA, but also do you have a covering prefix maybe that has a valid status or an unknown status, so you still want to send traffic to it. Then you can send that traffic and you can safely drop the more specific, but maybe if the more specific is invalid and it used to not be, you should investigate what the fuck happened. Sorry, what happened. So, and finally, we're talking about AS paths. And again, I remember many years ago when we started to talk about the man-in-the-middle attacks. And again, so we want to know what is happening to the AS path of the traffic we're sending. Is it as it usually is, or is it suddenly changing very dramatically? Do we want to figure out why that happened? And maybe we're running a service that has latency sensitive, so suddenly getting a longer path might also make sure that longer AS path may also mean that we have an actually longer route or longer, God, I can't find the right word, but we're sending it a longer way with higher latency, and maybe we don't want to do that. We need to go fix something, some policies somewhere. All right. So that's all very good. But how can we do that then? So I'm going to take another poll. How many here is using some sort of BTP monitoring tool already? Oh, that's a fair amount. Commercial or something you built yourself? Commercial, right hand, something you built yourself left? Okay. All right, you can just go to sleep or do your emails now then. And then the rest of you can listen to what we are talking. So when we monitor BTP, as I said, we are both looking at what's coming in, being announced into our network. That one is relatively easy because we can then look in our own routing table, keep an eye on what's going on, collect the data, and store it and do whatever, all the stuff that I'm writing that I'll talk about a little bit later about what we do. But the other thing is, how is your prefixes looking on the internet? Well, going back to the case we talked about before, announcing new space, I remember sitting there looking at one looking glass and then the other looking glass and then logging into route use and then doing greps, and it took a long time. I mean, I thought it was super, super fun. I was looking into the black screen with the green text on. It was feeling very, very cool. But it did take a long time. But I was actually using some of the data sources that I'm talking about here, and that's the route views and the routing information system, and then, of course, the looking glasses or your peers. So those are the data sources for this data that we need in order to monitor what's going on with our space on the internet. So somehow we have to get hold of that. And I think my next slide is actually a little bit about routing information service, which most of you probably know is run by the RIPE NCC. And we can all get access to the data. Most of us will just go to the web page and go and have a look and do queries. But if you're building an actual system yourself, you can get access to the whole data set and get it streamed to you in sort of almost real time, and then collect and build something that can give you the alerts yourself. Researchers are using this data set as well in order to try and figure out what's going on the internet. Route Use is American-based. It's run by University of Oregon and been around probably before I was born. Not quite, because that was in the Stone Age, but before I was educated, I think. And both these types of systems are collecting routes all over the world from collectors, so pieces of hardware they have installed all over the world, and is peering with whoever want to peer with them at exchanges all over the world, collecting the data, sending them back, storing it in big databases, and making them available for everybody. We all want to support it, so if you can, go support these people because they're doing good work. And both of them allow everybody to use their data, even for commercial purposes, as long as you adhere to the rules that they have set up for exactly that. So those, along with what we're learning from our peers, those are the data sources for a monitoring system. Then you need to be able to handle really large data sets and store them in a smart way so you can get the information out of them what you want. And you have to build a system that can query them in a time that is acceptable for you. And in particular, if you want to get alerts, set up rules and software that will give you the alerts when it happens. And then, because we're all very cool today, you also maybe visualize or present these data in a way that makes it useful for whoever is using them. We believe at Kentic that visualization is great, so it's one of the things that we try to do very much in our system, which is a commercial system. I will not run away from that fact. But the visualization, getting the information at a glance from a graph is very important and something that I think everybody is looking into these days. Right. And again, I'm going to circle back to the beginning. We believe that BGP monitoring is part of one bit of everything that you need to know about your network, no matter what kind of network you're running. Obviously, if you're an ISP or a big network with a lot of address space, it might be more important for you to monitor what's going on the internet. But most networks will have benefit from it and be part of why is this broken, or being alerted on, hey, there's something you should look at. And now it's time for questions and for you to tell me, what did I miss?
All right. Who's going to be first?
Really? I can't believe I didn't miss anything. Come on. All right. One last thing. We are here, 2 people. If you want to talk more about this or anything else, come talk to us. And finally, we are hiring, and we don't care where people live if they're good. So take a look at our website and go and have a look at the jobs. Thank you.
All right. So before we go to break, I just want to say that we have set up a table in the area just outside of this room on the left side where you can come and get your T-shirts. Everybody loves T-shirts, right? If you're unsure which size you ordered at sign-up, you can go and find your sign-up link. It should say directly there what size you had. So grab it at the break. There's a break now. It's half an hour break.
45?
45?
No, until 45.
Until 45? Yes. Yeah, because we are ahead of schedule. So 15:45, 45 minutes of break. See you then.
Until the dingle man goes and dingle with the bellies.
Yes. People were making comments having the announcements in here didn't do anything. Just couldn't hear them outside. So we need to be more belly.
Ladies and gentlemen, the conference will start in a few minutes. Please take your seats in the plenary. Ladies and gentlemen, the conference will start in a few minutes. Please take your seats in the plenary. Ladies and gentlemen, the conference will start in a few minutes. Please take your seats in the plenary. Ladies and gentlemen, the conference will begin shortly. Please take your seats in the plenary. Ladies and gentlemen, the conference will begin shortly. Please take your seats in the plenary. Ladies and gentlemen, the conference will begin shortly. Please take your seats in the plenary.
Welcome back. Welcome back, everybody. We're in the home stretch. Only 2 more talks until social. just have to be quiet for a while. The troublemakers over there. Yeah. Well, we have Emil Landstam that is talking about server-side automation with Ansible.
Yep. Hello. Sounds like you can hear me. My name's Emil. I am an AS engineer at Arista, and it's my first time at DKNOG, or indeed any kind of NOG. So I'm a bit nervous, but so please be nice to me. I'm here to talk about some network automation with Ansible, more specifically our Ansible collection called AVD. So first, just a quick agenda, a small, reason and motivation for this talk, although automation doesn't maybe need that much more motivation anymore. Like, we all know it's good stuff, right? Gonna follow it up with a quick overview of Ansible, and then go into what the AVD collection is and how it works. And then we're gonna see actually the collection in action in a couple of demos. So building a network from scratch could be considered like day 0, day 1 stuff, and then also deploying some services, so day 2 stuff, if you like to call it that. So consider this small, stupid topology of routers. If you wanted to get this to spin up some kind of VPN services on this, there's quite a lot for you to remember and to configure. Like, you have to set up your IGP, like your ISIS or OSPF. You have to set up your segment routing or your LDP or whatever it is. You have to configure your BGP relationships between the PEs. Look, I'm using the laser pointer here, and your route reflector, and all of that stuff, right? And then you have to configure your services on top of all of this. And it requires traditionally like a lot of copy-pasting stuff into the CLI windows, copy-pasting, hoping you don't make errors. I'm not saying anyone in here would ever make a typo, but except for me, maybe sometimes. Anyway, we kind of, with this AVD Ansible collection, we kind of want to do the heavy lifting for you. So you just have to worry about what services you want, and you can deploy them on your network. So real quick, although probably a lot of you are familiar with Ansible already, it's an open source automation engine owned by Red Hat. Mainly used for like server software provisioning, configuration management, stuff like that. It's very easy to extend and add functionality to Ansible with collections. It has this idea of idempotency, basically meaning like if there's no change to a device, we don't touch the device unless there's a change. So if we have our playbook, we run it, we do a bunch of changes to the devices, then if we run it again, nothing happens because we've already accomplished what we want. And it runs on mainly SSH and HTTP API, like open communication mechanisms. It's got a few components. The playbooks are basically the set of instructions that you tell Ansible to go and do this, and it does. And roles are basically your pre-bundled sort of bundles of tasks so that you can just reuse and import them as you want. Modules and plugins kind of extend how Ansible talks to devices and things like that. So then our collection here, which is called AVD, stands for Arista Validated Designs. It's made to design and stage and provision and maintain and test and document and do everything, provision your complete production networks. And we feed it, it's built on this kind of abstracted data model representation of the network that you store in your group variables as YAML. And then it generates, when you hit the playbook go, it generates the entire configuration for each device in the network. So all of the routers get their core links configured and everything, BGP and services and yada, yada, yada. It started out in life a few years ago, just mainly supporting layer 3 leaf spine, VXLAN, EVPN networks, so your basic cookie cutter DC deployment. Since then, it's gotten very, very flexible, and recently we added support for like these MPLS networks with segment routing and all that good stuff pretty recently. So, you know, EVPN with the MPLS data plane, or you can run VPN, IPv4, IPv6 address families. You can mix and match those in the same network. You can deploy your pseudo-wire services, your layer 3 VPN services, your layer 2 VPN services, etc. And it's not dependent on any kind of shady proprietary vendor software, controller software or appliance. So it's completely, you know, open source, free for anyone to use and abuse. Just spin up your favorite Linux distribution, install some open source software, and off you go. It's open for anyone to contribute to and add features. And it works very well together with our Cloud Vision portal. Now, Cloud Vision portal is not required for you to run this or any part of it, really. But it does add some value and flexibility to it. But I'm not here to sell Cloud Vision portal, so I'm going to skip over that a little bit. So the initial commit was 2019. Since then, we've had about 25 releases, 2,700 plus commits, 1,700 plus PRs from around 55 contributors. Those are Arista engineers as well as the customer community. And just small note, if you think the number of commits is low, it's because we squash each PR down to a single commit. And the main documentation page we have over there, installing through Galaxy, or if you're a developer or power user, you can clone it from GitHub directly. Kind of an overview of the roles, so how this thing actually works. So over to the left, we have this abstracted representation of the network in our group variables, the data model, that we then feed into our first role, which is called EOS designs. Now, what this role does, it basically generates a structured config file for each device in the topology. So basically, your CLI configuration, except it's in YAML format. And this is really nice. Some of you might ask, why not just render the CLI config directly? There's good reasons for that. Anyway, we then take that and run it through our second role, which is called EOS CLI config gen, which then is responsible for generating the CLI configuration for each device. So that's good. After this step, we just kind of have like a complete CLI configuration for each device in the network covering everything. We then use that together with the Ansible inventory with one of these deployment roles. So if you're running CVP, you're going to want to be using, the CVP deployment role. If not, you can just deploy straight through the API, eAPI connection to the devices themselves. And the end result being that the devices are fully configured over there. Some additional stuff that this does. AVD, we kind of talked about documentation and how it's pretty difficult to keep it up to date. And we kind of propose that your automation should really auto-document your network for you. So AVD does this. It generates markdown files with fabric documentation and per device documentation as well. And it can also do automated on-demand network ready for use testing. So it can actually go out and test, and this is where we use this structured config that I mentioned before. We can use the structured config together with the inventory to go out to each device and make sure that all the PGP neighborships that are supposed to be established are established. We can check things like the LLDP topology to make sure that there are no miscablings that might be difficult to catch otherwise. We can check, I already mentioned BGP neighborships, but we can check interface states, routing tables, that all the little loopback addresses that we want are in each routing table on each node. NTP sync status, we can check the power supplies and fan status and all operating temperatures and all that good stuff. So we can do that pretty much in an automated fashion whenever you want, if you want to run it nightly or whatever, right? So demo time. Cool. You remember the topology, hopefully. This time, this happy little operator guy, it's me. You can see the resemblance, I think. It's very happy because now he has Ansible to do kind of the heavy lifting in terms of generating and coming up with a configuration and deploying it to the devices and stuff. So we have an ISI segment routing network with running the EVPN address family as the overlay. And we're going to start out with all of the devices. Now, these are virtual devices, but it doesn't matter. It works the same for the hardware. They're just virtually racked and cabled and in zero-touch provisioning mode. We're going to have a quick overview of the group variables, i.e. the abstracted network representation. I don't know how many times I've said abstracted network representation in my presentation, but a lot. Then we're going to run the playbook to deploy the network with the underlay and overlay stuff. And by that time, we're going to be done with the first part of the demo. Take a minute to take in this awesome slide. Demo 1, go. Ah, cool. Okay, so we're starting out in the Ansible inventory. This should be familiar. I hope you guys can see this, by the way. Should be pretty familiar to anyone who's worked with Ansible. We define the CVP instance, the top-level group for the network, and our different routers, hosts, RPs, RPEs, and our route reflectors, and all that. We then go into this kind of group variables where we define the basic stuff for our network. So we give it a name, we give it some TILFA stuff, we give it some BFD information, which BGP AS to run, and then we define our nodes. So for our P routers, for example, some defaults for all the nodes, like the platform, the loopback pools, and the node SID bases, and then some IDs and management IPs for each device. And it's much the same with the PEs, but it's a bit more because now we have some services here, and BGP, so we need some BGP defaults there, and they need to talk to some route reflector device somewhere. And then it's much the same node definition here, so we can actually also use these tags to filter which services are eligible to be deployed where. And then our route reflector is kind of simple also. And if you put two nodes in the same node group of route reflectors, they will automatically form a cluster also. Cool. Let's see. I don't think it's, yeah, it's going. Cool. So management settings, super interesting. I don't know why I kept this in the recording, but anyway. Yeah, same for this. Very interesting. And here we have the CVP instance, basically a blank slate. So what's happened here is that each of our virtual routers have gotten a DHCP lease and been like zero-touch provisioned into CloudVision. And we're just going to hop on into a router here and then make sure that it is in zero-touch provisioning mode. This is how you get it when it comes out of the box from the factory. Oh, typo. I told you I was going to do typos. So anyway, this is just what it looks like when you receive it from the factory. Super interesting. And then back to CVP. So blank slate. All of the routers are in there, having received the DHCP lease. But we don't really have anything in terms of configuration for these yet. So that's what we're going to go and generate with the Ansible collection. So we just run the playbook here. And text starts scrolling. Should also be very familiar to anyone who's used Ansible, which I hope is at least some of you. As we can see, it generates what it's supposed to generate. Just having a quick look, there are no configuration objects, no tasks or anything in CVP. But God willing, there's about to be. Cool, so now it's talking to CVP, it's uploading this yeah, you can see here it's generated a configuration for each device. So you're with your core links and your loopbacks and everything, management stuff, BGP, your ISIS protocol, all that good stuff. And now things are starting to happen here in CVP. So it's built this container topology based on the Ansible inventory groups, actually. And it is now kind of moving these devices into the container topology, and it's built these configuration objects for each device. It's attaching them to the devices, and now we get to see, yeah, the playbook has finished running. Awesome. And now we get to see what it actually wants to do. Yeep. So we're going to review the changes, and design configuration here on the left, running configuration on the right. Green is added, blue is modified, and red is removed. As you can see, we changed the BGP running mode to multi-agent. We have a lot of scrolling to do, apparently. And it's all here, the BGP stuff, the core links, the ISIS. So let's approve and execute, and this is gonna take a few minutes, mainly because the first time you deploy this stuff, you wanna change the routing BGP agent to multi-agent mode. This requires a reboot, so it's gonna say that it has completed the configuration push, and it's gonna, check that the device is rebooted for a while. And also this lab is running on my ancient home setup, so it's very slow for that reason. Anyway, it doesn't matter. Video editing to the rescue. And now, after that's deployed, we should be able to see that the ISIS adjacencies are up here. Yeah, cool. It's almost like I've seen this video before. ISIS is up. We have the routes for the loopbacks in our routing table, so the PEs here, and the route reflector, and the P nodes also. Yep. Doing the things. And then we also check the route reflector, just for good measure, to see that we have an EVPN session established to each of our PEs, and we do. But there are no services here yet, so it's quite boring. But hey, we got some of the way there, at least. So now at the end of the first demo, as I've already mentioned, the network is deployed. ISIS adjacencies and overlay BGP peerings are up, but we have no services. So there's no traffic going across the network in any shape or form. We'll go ahead and define some services in the group variables, in the abstracted network representation I've mentioned so many times by this point. We're going to run the same playbook again, so regenerating the configuration for each device, and we're going to see some services get configured and deployed. And we'll be ready for production, hopefully. These are the services we're gonna build. So we have a layer 3 VPN service running between the two sites. BGP as the PECE protocol there here on the left, and OSPF here on the right, just because. We have a VPW pseudowire service. It's a multi-home service. And a layer 2 point-to-multipoint style service as well. Also multi-homed. And we're gonna, with a little bit of help from our friends, or our AVD collection, I guess, we're gonna get these things going. So another video. And I actually wanted to do this part live, but reasons I can't. Anyway, we're gonna start by just looking in the CE devices. Make sure you can see the lower layer down there on the interfaces that should be connected to the services. Then later on, we don't have our port channel up or anything to the PE. We can't ping inside of our services for obvious reasons. They're not there yet, but just you know, just wanted to show that for some reason. Anyway, network is unreachable. Cool, that's kind of expected. So here we are in our group variables again. We define the tenant, some basic information for the tenant. And then we start out with the point-to-point service, the VPWS pseudowire service. It's got a name and a type and 2 endpoints, which are basically 2 pairs of PEs, their interfaces, and some stuff to make it go, you know, active-active, multi-homing, EVPN coolness. Then we have our point-to-multipoint service, so our EVPN straight-up VLAN. And we use the tags here to filter which sites it gets deployed to. Then for the layer 3 VPN service, we have quite a lot of stuff. So we have the VRF. We give it a name, an ID, which address family to use. So here you can imagine we could use VPN IPv4 instead of EVPN, for example. Then we have some SVIs at each site to kind of terminate this. And we could also be using like a normal routed interface, of course. And then actually at the site 1, we have a BGP, tenant BGP relationship right inside the VRF. So we define it there as well. And also, since we're talking VLANs, we need to define the actual layer 2 port channels that connect to the hosts. Or to the CEs, sorry. And this is how we do that. So we define the endpoint ports, the switch ports, the switches involved, and some EVPN active stuff here as well. And just cleaning some gunk out of the out of the file before we press play on the playbook. Apparently. There we go. It's very exciting. Scrolling text again. It's awesome. Now we can see some stuff has actually changed for the PEs. And we should be able to see some tasks popping up here soon again in CVP. Yeah, there we go. It's happening. And here we can see this kind of item potency thing in action where it doesn't actually touch the devices that aren't changed because we're only changing the PEs. And so here, as you can see, we have a bunch of VLANs configured. We have, you know, our VRF instances and port channels, etc., with their EVPN active-active configuration on them. Everything good. We have the patch panel where we patch the interface to the pseudowire. We have our BGP stuff here, which I'll expand soon. Any second now. Yeah, there we go. Awesome. All of the BGP stuff, so the EVPN VLANs, the BPWS instance, the whatchamacallit, the IPVRF. Etc. And then your ISI stuff is the same, basically, because we already did that. And we have our OSPF instance also. This is a Site 2 PE there. So that's all good. Scrolling through it. Very nice. And then we approve and execute this again. And a little bit faster this time. So just a couple of minutes. Again, down to the slowness of my ancient home lab here. Awesome. Looks like it's a success. So now we should be able to kind of go into the CEs and verify that everything is up. So we have the interfaces are in the up state now. We should be able to ping inside, you know, across to the other side of our service. So that's some pings going there. Great. That was the layer 2 service. We should also be able to have a look at our pseudowire service. Ping across that. Yeah, we all know. We all know if ping works, then everything works, right? You don't need anything else. Oh yeah. I'm gonna ping the gateway on our side first, for some reason. We're going to try and check that we have some BGP routes here received on our CE device, and we have. So for the remote side network, and ping inside the L3 service here as well. Great. And now I'm going to ping an address that doesn't exist. That's why it doesn't reply. Just to, again, with the typos and everything, right? So other side looks to be responding here, so that's all good. We're going to hop into CE2 also. I guess we're going to check that our BGP relationship is up, but we already know we have some routes. So anyway, might as well, while we're here and everything, established and some prefixes exchanged. Cool. We should be able to see in CPE2 here that we have our interfaces up. We should see some OSPF relationships also established to the PEs. Great output there. Hopefully a little bit better one soon. Yeah, awesome. Okay. Yeah, the routing table again. Just to check that we have some OSPF routes in there, and we do. So that's all good. And our services are now kind of officially running and active and working. And that, I believe, is the end of that demo. Yes. And also the kind of the end of my time. So if you want to discuss or reach out to me or discuss this automation or the weather or whatever, just shoot me an email. Yep. Any other questions?
We had a question on the chat, and let me just read it aloud. We have a question from Ravi from, let's see, Delta Fiber in the Netherlands. He's wondering if you know anything about the availability of multicast VPN on EOS.
Multicast VPN on EOS. I mean, this is an automation talk.
Yep.
So I don't know.
Okay. Is there any?
Ask your SE, I would say. Yep.
Hello.
Hello.
Thank you again, Matthias from Cisco. Wonderful talk. I was just curious, the playbooks in your example, are those publicly available to peruse? I'm just personally curious how different your Ansible things are from ours, and I want to broaden my horizons. Is that also on the same GitHub, or otherwise I'll just email you if I can't find it? But
yeah, just shoot me an email. But it's on this. It's not on the same exact repo, but there are example repos, and just shoot me an email if you can't find them. But avd.sh is where we have all the documentation, and we have a bunch of examples and everything there. Any other questions?
Anybody? If not, I would really like to thank you. I mean, especially doing the live demo in video slides is not an easy thing to do, so thank you for that as well.
Thank you for having me.
And before we head to the final talk for today, just a reminder that there will be buses after the talk. They should come pretty quickly when we're done. And I would also like to remind you that there are surveys posted for every talk for today. So please fill them out while you still remember what this thing is about and haven't had too many beers yet. It's my absolute pleasure to invite our final speaker for tonight, which is Måns. He's coming here. Another fellow bowtie wearer, I always appreciate that. He's going to talk about timing in the television network.
Thank you. Hi. Yes, big green button, right? Let's see if this works. I'm going to talk about timing and synchronization in new network broadcast systems. And what the hell is that? Okay, hang on. So, about me first. I've been doing network stuff for a couple of years. I've never been to DKNOG, so this is my premiere here. I've mostly learned things from more competent people around me. Doesn't mean I'm competent. And there are giants on which shoulders we're standing. I would just like to acknowledge that. Jag har så gott lyssnat dansk. But this is an English presentation, and we'll stick to that. But I'm not a stupid Swede who doesn't understand Danish. Be warned. Anyway, so let's dive in. So what we're going to talk about first is the origins and needs of media synchronization. And the picture here is, this is a cathode ray tube, a fat TV, for those who were born this millennium. And it's the thing that basically is the origin of synchronization in media, with film frames as a strong runner-up. And the technical needs of the cathode ray tube, how the electron gun draws the picture on the scope or on the cathode ray tube, is what governs sync systems for media still today. So if we just look at how we perceive images and sounds, this is a very good illustration from a US Navy instruction film that's old enough that I can use the picture. And what you see, let's see if we can get a bit multimedia. Yeah, this is the sound. This is a linear representation of the waveform. These here, sorry, let's go back and press the right button. These are moments in time. These are fixed moments in time that our eyes and brain are making movies out of. This is a very important thing to understand for media synchronization. Now, of course, if we take and digitize the sound, we will also have moments in time in sound, but they will not be 24, 25, 29.93 if we are really perverted Americans, or 50 or 60 or 120 frames per second. They will be 48 kilohertz. And that is not Kelvin hertz, Mr. Jugbeck. That's kilohertz. That's my... I did write kilo with a big K there. Sorry. Anyway, so further, we need to ensure that sound and picture are in sync. We need to make sure that this... And we have a fairly small window. One frame which in PAL land, which we are here, 50 hertz, is 20 milliseconds. And most people can find out within 1 or 2 frames if the sync is off, without training. And sensitized people are even better than that. And of course, the only way to achieve synchronization is to wait. You cannot speed the world up, not in real time. If you're cheating with files, of course, but that's not the case here. So there is a startup opportunity for the one who invents the earlification device. I've been waiting for 30 years. It's not here yet. Yeah, so screen revolution. The CRT, the fat TV, is a hipster thing. We don't need to steer the electron gun. It's basically we take a blob of bytes representing pixels and throw them at the screen. Still at the frame rate, but it's just a blob of pictures. Or blob of pixels. So we don't need to sync. We don't need this 50 hertz beat. Basically, analog sync is a black TV picture and nothing else. But it has the framework inside to say now. But we need a reference because we need to know where we are in time so that we can take sound, picture, several pictures, merge them together and make the moment in time synchronization happen at the same time all through. So this means that we need to talk about when, not how frequently we took in a picture. Because if we have compression, we might have a still. That still might be valid for 2 hours. We don't need to refresh the still every 20 milliseconds. It might be that, this slide, for instance, is valid for several seconds, for instance. So we can, if we know the when, we can decide the offset. And we can tell the other media streams to wait and display this in synchronization. And this is valid for every digital transmission of video pictures, even if we're using BNC cables and SDI formats and so on and so forth. But we want to do this over TCP/IP because Ethernet is so cheap and good, right? I used to run SDH. Anyway, so what this boils down to is that modern TV production is increasingly networked because the fact that we want to look at cat pictures and cat movies and that the bandwidth demands and the standardization onto Ethernet switches that actually also can look at an IP header, top of rack, 1U, pizza boxes, switches, routers, they're cheap. They're extremely cheap compared to what you get in a traditional media switching system, if you just look at the bandwidth. So, and of course, the multiplexing abilities of TCP/IP are quite astonishing when you're used to having to buy a new interface card when you go from progressive to interlaced scanning. In RTP, which is what is being used the most, it's just a flag. Software-defined picture transmission. That's kind of nice. Of course, TCP/IP is the Wild West. There is no timing, there is no control, and all the telco people are running around scared because there is no one who is in charge. Especially on Ethernet. I mean, token ring, that was nice. An SDH, yeah, clock. Anyway, so what we do is that, of course, we use the multiplexing ability again. We have a service on the network. And this time it's, I shouldn't say on, it's more embedded in strange ways. PTP, SEMPTE and AES, who are the standards organizations for film and video and audio respectively, they've decided to use IEEE 1588 2008, which is PTP version 2. Then there are infidels who are using PTP version 1, and of those we do not talk. That might include the mixing desk at the rear. I haven't looked too close. Anyway, so this is not your common usage of PTP. I mean, there are industrial uses for PTP that are pretty close to ours. You have automation, you have... Oh, we have pictures. You have automation, you have power system switching on time, and so on and so forth. And you have navigation stuff, and so on. What we do care about, not so much the offset to UTC, and we don't go to the International Bureau of Times and Measures and compare our Allen deviation every 6 months. That would a proper time not do. We don't. We just care about the timing island we have built to 1 microsecond, which I am quite proud is slightly narrower than 5G. 5G requires 1.5 microseconds. And there are indeed islands. The island is fairly small, and there are lots of rubber buffers. Think of the large airplane full of tapes analogy, or TCP with buffering, and delays between the islands. A lot of it. And of course, this being broadcast, there is a lot of cargo cult. There are lots of people who know perfectly well how traditional video works that don't have even a shadow of an idea how we people actually transmit bytes between places. They are really out in very deep waters. And the vendors, of course, they have found out this. So they learn just a little bit more, just a little bit more than the users. And then they find, oh yeah, let's package this and let's make it so it barely works. Put it on the show floor and sell it. So yeah, there's a lot of voodoo. You can't have that if you want to buy from more than one vendor, or if you actually want to have something that works even when the vendor support is, huh? So, let's see here. Button. 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 Which way do I point? Or is it just... Can you forward move slides for me? This is standing between you and your beer. That is not a good thing. Okay. Most likely a timing problem, yes. Okay, so I'm backing and going forth again. Yes. So, a little bit of a word around standards. We've got AES67, which is the audio transmission standard. This linear audio, CD quality, basically, but 48 instead of 44.1 kilohertz over multicast, RTP. Video is pretty much the same thing. You take a video frame, uncompressed, and dump it into RTP, and then throw it on the network using a time reference from PTP. So it's basically just IP multicast. There are an interesting mix of fat and thin streams. The audio stream for a stereo pair is about 2.3 megabits. A uncompressed 1080p frame is about 3 gigabits, give or take. So what you can say is the SEMPTE and AES67 standards are paywall versions of IETF standards compilations. So you can mostly realize what they are by reading RFCs, but then you have the PTP standard and so on and so forth. So, as I said, RTP timestamps headers reference to common clock distributed by PTP. Same method for video and audio. And where it gets interesting, I've chosen an example out of reality here, which is synchronous or synchronous choice for audio. And that's basically, do we buffer wait to get in line? We can use the timing information in PTP to steer the sampling frequency only, and then take the sound as soon as we have it. Or we can take it and look at the timestamp but playing out in sync. And I have a few pictures here. The first slide version here had a Tintin picture up in the left corner. I have to change the dictator here a bit because he has lots of microphones in front of me, and that's why I chose him. Because what you have here is that you have two audio streams coming from the podium. They are being taken care of in these two analog to digital converters that make RTP and put them on the network in the middle. And they are being transferred to the mixing desk over here via two network latencies. They're not very much different, these two latencies, but there are differences. And then we go to playback after having mixed the streams. So we have two microphones working together, picking up the same sound, and that ends up in the same playback. And now let's see if this PowerPoint is better than the other PowerPoint. This was supposed to be a movie. This is a Lissajous pattern from two tones on an oscilloscope. This is what happens when you have two unsynchronized streams. No lock between them. If we do synchronous, we have two tones. I am imagining that the dictator is just saying foul words, so this is roughly a 1 kilohertz tone, blocking his foul words out. And you have a latency between the two streams. And this is if you only lock to the sampling frequency. If you actually look at the timestamps and align the samples synchronously, you will get to this. No, there is a bonus picture. Hey, this is Danish phase difference. Everybody who's done the XY experiment on an oscilloscope recognizes this, and I call this Danish phase difference, obviously. Now, let's go further on. So the synchronous picture is this. The signals are in phase. Actually, I cheated. This is only one tone, but it will look the same and it will sound the same. That's the important part. The synchronous text label here is very, very cleverly placed over the on button here, so you can't see that the second input on the oscilloscope is actually off. I've now admitted as much. Anyway, further on. We want to build a timing infrastructure so that we can actually use this. And now we're coming to the network engineering part of this 15-minute warmer-up. So what we had was a project at SVT to replace the legacy sync, the actual old box. So old that you would never ever dream of deploying or having something so old in your network, right? 15 years, I think. What we needed, and we had realized this fairly early on, very, very, very hands-on realization, that all forms of timing needs to be referenced to this common time frame. It might be blackburst, which is a black TV picture, tri-level, which is a modern digital sync, word clock, which is the digital sound sync, SEMPTY clock, which is time, which actually looks like a clock with 50 frames per second. NTP, PTP, 1 impulse per minute, like in this clock here. All those need to be synchronized. So what we decided was, after some initial less impressive tests, to make PTP king. But we still need all the other ones. We have 60 years old impulse clocks that we want to steer. So we have this time span or history of functions that we need to support. So what we did was we built a lab environment, and then we did productions in it, including the largest remote production we've ever done. Doing that in a lab environment is interesting, it's educating, and you very quickly learn what not to do. We first tried to build a synchronous island where we didn't talk to the old gear. That didn't work. We locked then to the legacy. That was quite Heath Robinson, which is, now I don't remember the American equivalent of Heath Robinson, but Rube Goldberg, thank you. And we ran this for a year in production. I do not recommend this. Don't. Do it right from the head on. So what we actually did when we did it right was to do something like this. We bought 2 GNSS steered clocks. You need to have a very good clock to start off with. You can buy PTP services if you want, at least in Sweden. But we decided that it would be less hassle to just buy 2 GNSS receivers with PTP output. And then we have, and they are very small in the picture because that's how I made the drawing, 2 switches, distribution switches. And then we have down here 2 sync generators. What they actually do is they listen to PTP and they output all the old stuff, except the 1 pulse per minute stuff that's being abstracted over NTP on a separate path. And then there is a changeover unit because the legacy formats, they can't choose between 2 clocks. They need to have a clock. So you have a relay-based box that selects between the 2 sync generators. And if one fails, it takes the other one and so on. Now, network-wise, PTP is not an ITF protocol, and you can tell. It's a level 2.5 word. More. I really understood it when I started to look at it as SDH clock. You have a clock going into something, and then it's being used to drive that device, and then that device drives other things. Then there are transparent PTP switches. I don't like them. So we do, because a lot of our gear requires a boundary mode when you have a clock in the switch that actually reclocks and makes a new PTP clock. We run everything in boundary mode. And the distribution switches, let's see if we can go back, the little blue ones here, they run level 3 links to all consumers. So there is no routing through. It's just hop by hop. So PTP is hop by hop. It's very important to understand that. And yes, as I said, there is the theoretical possibility of having a transparent or non-aware switch in this. None of the good things do that for a reason. Anyway, we need hardware support, of course. It's required. You cannot build this as you would a normal ITF protocol on a stupid switch. You need to have the hardware support in the device, or it won't even get close to good enough. And of course, it's an IEEE protocol, so it's full of options. The power people wanted their profile, the telco people wanted their profile, the SMPTE people wanted their profile, and the audio people in AES wanted their profile. And they all differ. So you have to configure. And there are parameters on how often you send messages and so on and so forth, and they have to be aligned over the link. There is no learning. You have to do it right. And the expensive switches can send more clocking packets per time unit per port, which is good because it makes for a better synchronization. And the cheaper ones can't. So we need to follow on in what the hardware is available, what kind of capabilities are available in the hardware. Now, there are a few devices on the market that aren't sold as switches, but they actually work like that. And media converters, if you have to go from fiber to copper, there are very many of those that are Ethernet switches. Of course, they're only 2-port Ethernet switches, but they're still switches, which means that they buffer the frame, and then when they sort of feel like throwing the frame out, they do it, creating packet delay variation. Jitter is something that only salespeople say. And the other prime example is the divide by 10 OADM. When you have a 10 gigahertz wavelength over Ethernet, and then you switch it down to 10 1 gigabit Ethernet connections. That is timing-wise a disaster. Don't buy those. Always buy the full frame, the full bandwidth of one channel. And then you can do 600 kilometers, no problem. I've done it from Stockholm up to Norrland in production. It works, no problem. And if you're going to build this, you really need to know a few things. You have to know what clock hierarchy you want. The grandmaster, the actual hardware with the antenna, that needs to be king, and it needs to be king all the time. This is a hierarchy, and you really need to enforce it. There are a bunch of things in the PTP system where you have the distance to the grandmaster clock and the quality of the clock that are influencing something that's called BMCA, Best Master Clock Algorithm, which is a selection process that runs pretty often, about once a second, I think it is, where every PTP-speaking device decides if it's going to be king or slave. And that goes per PTP link, PTP-enabled link it has. It can, of course, only be slave on one. It can't have two masters. And if you're going to build a multiple path, let's see if this is the right picture. Yeah. So if you have a multiple path scenario where you have several possible ways your PTP traffic could flow, you need to be able to decide which is the normal one and which is the failover path. And this is roughly how we've built. The consumer does have two paths which it can receive the timing information over, but it needs to select only one. And you want this to be stable. And of course, you can't buy IP over MPLS or similar crap. You need wavelengths. Don't buy that crap. If you're selling it, start building it better. Anyway. So, and then of course you have the priority thing. If you have a lesser switch, you need to be able to put the PTP in the best queue possible, above everything else. Routing protocols are slow and non-demanding in comparison. PTP wins because it needs to have the best possible queuing of everything available. and don't use copper. The error correction in a copper transceiver adds PDV compared to the optical transceiver. So use optics even for short 1 gig runs. And of course, I talked earlier about bubbles, where we have one sync site there, one sync site there, and we want to run traffic between them. This is a work in progress. We don't know how we're going to do it. We are in a big project with our network vendor, and we've told them that we want to explore the design where we have clocks only in one town. And then we have backup clocks, because a few of our network devices have GPS receivers built in. So we can use them as a very cheap secondary source if we have failures. But the design idea is to always have the master clock in the main office first, and then only degrade to the local clock if we really, really need it. And the old design model for doing media is that you do TV in one house, and then you rent a connection to another house. And that rent might, of course, be picking up your phone and dialing the connection office and asking for a connection from A to B, just like they did in the old days with the manual switchboards. We want to surpass that and have a country or company global media network where the user is king, or the user needs can be satisfied by the user himself or herself. So, and we do distribute our production system so much that we need this transparency. Well, does it work? This is a screenshot from one of our testing instruments. It's a fairly short one. It's just 2 hours, if I remember right. And we have a timing error on a link here. It's about 250 nanoseconds for a fairly short fiber run. Over this, we can get something like 10 to 15 nanoseconds precision. And with increasing radius of the network in terms of switch hops, we of course get the degradation, but we rarely go below 50 nanoseconds in lack of precision when we do, say, 5 or 6 switch hops. If we do it right. It's sometimes tearing your hair out hard to actually remember which parameter it was. Might be a case for some kind of management deployment. I don't know. So basically, every frame of video you've seen from us, if you watch us, when I was a kid, I watched Danish TV, so I suppose that every Dane watches Swedish TV, or did when they were small, at least. So since March 21, we've run PTP clocking as the main timing information source for every video frame we've made public. Yeah, that's it. Questions?
Hello, Jordi from Tilia, Denmark. I wanted to know more about, you mentioned that if you have 2 paths, so several paths to routers, you really need to define your primary. And then I was thinking, what if your router is equally distanced to the both grandmaster signals that you have? How can you force that primary to have a stable signal?
What you do is that you play with the priority parameter in the clock on the switch. So the first thing is that you need to decide that the grandmaster and the grandmaster candidate, the 2 GNSS devices, have the lowest priority setting, which means they are more important. And they have the lowest priority setting of any device in the entire network, which means that they will be king as long as they are reachable. And then if you have a scenario where you have several paths, you need to actually decide this is going to be the good path, this is going to be the bad path, and you tweak the priority 1 and in some cases priority 2 on those devices so that you create a stable situation, because BMCA does run, but it shouldn't come to a different conclusion unless the topology changed. Agree? Yeah. Thank you.
Jan Krillesen, Nordlys. My question goes about the situation where you cannot get something like VDM or dark fiber. Say, for instance, you have an OB truck out doing maybe a football match or a large concert production or something like that, where I would assume you have some kind of local synchronization between the different cameras, etc. But then you also have a link back to the production facilities. That would probably be running over some kind of Ethernet. How do you manage the synchronization there?
What you do, if you need PTP synchronization out there, you don't need it for everything all the time if you have legacy equipment. I mean, a lot of those productions are legacy equipment that have some kind of old synchronization, and then you just submit the signal. But assuming that you want to have PTP synchronization out there, you can build a sync island with a local clock, and then you can transmit that signal with the timestamps, but without a PTP relation between sites, and you can receive it, and you can clock it to the house clock. It's possible to do that, and most people who do build distributed systems do it that way. It means that you need to have some buffering on the path, because you have, if it's a soft path, let's for instance say that it's an MPLS service, you will have to have something that buffers for PDV, buffers per packet loss, which you really can't deal with, but actually mostly PDV. So you can do it, but you will get less quality in terms of low delay. And that's a production problem rather than a distribution problem, because if you have links, let's say comms links, people are talking across, then latency will be a problem. If you're just delivering a finished program, 250 milliseconds of latency is not going to be a problem.
Right. Okay, thank you very much.
Thank you.
Anyone else?
They want beer. But we need to talk as well.
Hello, Thomas from TDCnet. I'm curious, how is your, it seems like you used GNSS, maybe GPS or whatever, satellite system for the primary clock. What is, if that is disturbed for some reason, jamming or whatever, what's your holdover time? Do I have any design criteria? And then I was interested in if you can't achieve that, what's the consequence, that the picture and sound will go out of sync, or will it break down?
Yeah, I understand. Well, what we need to think about here is that, as I said earlier in the presentation, is that the actual accuracy to UTC is not as important as the fact that everything is going in lockstep in my island. So as long as I have a reasonably good holdover clock, and I have overnight oscillators in the GNSS receivers and so on, so I have a fair amount of holdover there. I haven't tried this, but I also have two, and they are slightly moved apart, and they are also using a bunch of different GNSS systems. So I have a mix, which means that I will probably have at least one that's reasonably well working. On the other hand, on the other side of the street, we have the US Embassy. And we've seen GPS jamming, not only from Polish trucks, but also from other people. Because we had a president visit, and there was completely havoc in GPS. So yes, it's a bit of risk.
Hello. I'm just curious here as a follow-up question. If you say that accuracy to, this might be a dumb question because it's late in the day, but you say that accuracy to UTC isn't that important to you. So why are you buying these GNSS antennae in the first place?
basically because I want a clock that is very stable in terms of how long a second is.
Ah, okay. So
Basically, I want a monotonically, boringly good clock. That's the case. And if it's locked to duty C, all the better. But it's not critical. It's the...
that's the cheapest, most efficient way of...
Yes. It's a very cheap way to get a good beat. I mean, I would love to have a cesium normal in my basement, but who wouldn't? I mean, it's completely normal.
You mentioned you have... I'm Mikkel from Subspace. You mentioned you have 2 of the standards. Have you considered having 3 so you could actually figure out if one of them is broken?
Yes, and we do.
Okay.
So yes, we are listening to several protocols at the same time.
Anybody else? Please, thank you, Mogens, very much.
My turn.
And now, standing between you and the beers is me, saying that there will be buses in a second. They'll be here at 5 o'clock. And there will be no buses back. So you're on your own as soon as you're out there. See you tomorrow or tonight.
Maybe tomorrow. Now that you've done your first